Good morning, everyone. Thank you so much for joining us. We're just going to wait a couple of minutes as all of our participants and attendees file in. We're just going to give it a minute. Good morning, everyone. Give it a couple of minutes as all of our attendees join us. Thank you so much for being with us this morning. All right, I am going to go ahead and get started. Welcome. It is wonderful to see all of you here, all of our teams with the American-made Solar Prize, as well as many of our colleagues at the DOE and the National Renewable Energy Laboratory, and many of you who are attending out in the world. Very glad to see you this morning. This is the final day of CMU Energy Week. It's been virtual this year, and I wanted to just welcome all of you to our last day, which includes a pitch showcase for the American-made Solar Prize Round 5 set hardware teams. So very glad and excited to have you here. Next slide. Thank you. I just wanted to say a quick welcome and thank you. I know I said some of that before. Many of you I have not met. I'm Anna Siefken. I'm the Executive Director for the Wilton E. Scott Institute for Energy Innovation. So who are we? We are a research institution in Pittsburgh, Pennsylvania. We sit within Carnegie Mellon University, which many people are very familiar with. But we are the hub for energy and climate tech innovation on campus. So we work with faculty in sort of traditional ways, but we also do a lot of work with entrepreneurs and with students. So very excited to have you as a part of our activities. All of our work is to drive us towards a sustainable, low carbon energy future. I want to make sure that you know how to get in touch with us. And so we have a website, we have newsletter, we have a number of different ways that you can follow us on social media. See them. Next slide, please. But I do want to thank, especially since it's the end of Energy Week, two of my esteemed colleagues. So Caitlin Haas-Conrad is the Assistant Director for Partnerships with the Scott Institute, and Kristen Whitlinger is the Digital Communications Manager. I'm going to stop for a second and give them a huge round of applause for all of the work they've put in to put this event together this week. You know, we do a lot of in-person events and we're looking forward to doing those again, but these virtual events take a lot of effort too. So a lot of thanks for those folks. Can we go back to the PowerPoint? All right, so I want to tell you about a couple of things that are happening today before I introduce our esteemed advisors. So later today, we have a couple of things. We have a networking mixer that's from 3:30 until 5 o'clock. It's in the Remo platform. During that time, you'll be able to meet with investors who have tables. You'll be able to meet each other. And there's sort of several hundred people who will be there. So really excited about that opportunity. It's between 3:30 and 5 o'clock. You can use the QR code on your screen to register if you haven't done it already. Next slide. So today we have 15 teams that are going to be competing. These are actually the hardware teams today. So let's go to the next slide and I'll give you a walkthrough of the agenda. So we're going to have pitch presentations this morning until about 12:40. Then we're going to take a lunch break where we want everyone to go off screens so that we can relax for a few minutes. We'll come back at 1:10 Eastern. And then I do want to mention that between 3 and 3:30, before we all jump over to the Remo platform, there's an advisory panel discussion with some pretty amazing advisors. So throughout the week, we've had some incredible investors, advisors, experts that have joined us, and 5 of them are getting together with us for that panel. Next slide, please. So I do want to introduce you quickly to our panel today. It's a really great group. So we have Joe Barron from Mitsubishi Electric Power. Gautam Fonts is from Chevron. Andrew Chabot is from AMP Energy. Stephen Stella is from EPRI. Trisha Dinkle is from NECEC. Adria Wilson is from Breakthrough Energy. Jason Gress is from Innovate PGH. Cole Wolfson is from XBridge, Pittsburgh International Airport. And Sasha Mishri is from Microsoft. So before I pass it over to Caitlin Haas-Conrad, who's going to walk us through the order of presentations and give us a few of the additional ground rules, I wanted to also say a special thank you to Sarah Gomash from the National Renewable Energy Laboratory, as well as Jackie Petrie and Emily Evans, other folks at NREL that have really helped to make this possible. So thank you to those folks. And with that, I'm going to pass it over to Caitlin. I'm looking forward to watching the entire day. I will see you all at 3 o'clock, and then looking forward to networking at 3:30 as well. Thank you, Caitlin.
Hello, everyone. We're actually going to have Sarah give a welcome from NREL quickly, and then I will go through the rules and order for today. So take it away, Sarah.
Great. Thank you so much, Caitlin, and thank you so much to the whole Carnegie Mellon University Scott Institute team. My name is Sarah Gomash. I'm with the National Renewable Energy Lab and the team that is running the American-made Solar Prize. We are very excited to have the Scott Institute as one of our power connectors for our program. This means that over the past few years, this team has provided a lot of support to entrepreneurs going through our program, providing them with opportunities like this and really helping them refine their businesses. I'm really excited that you've joined us today. The teams that you're hearing from are competing in round 5 of the American-made Solar Prize. About 4 months ago, these teams were selected for their innovative ideas to help move solar manufacturing in the United States forward. They've been working over these past 4 months to take their ideas to proof of concept. You'll hear from them today in the work that they've done and where they're trying to go. And so I just encourage you to listen in. We've been really excited to see the progress that they've made, and hope that you'll join us in supporting these teams as they continue their pathway from proof of concept to prototype and beyond. I also just want to say on behalf of NREL, we are very excited to be working with the U.S. Department of Energy on this. This program is funded by the Solar Energy Technologies Office, and so we're so excited to have their support for these teams today. Thanks, Caitlin and team, and back over to you to get the day going.
Thank you very much, Sarah. We've had a great working relationship with NREL, and we're very excited to have them with us today, both during the showcase and during the mixer and the advisor panel. So for our first session, we've split the day into 2 halves. We will have 7 teams presenting in the morning. We're going to start with CFV Labs in a moment. These are the 8 teams for the afternoon after our lunch break. These are the pitch presentation guidelines. As you know, each team will have 5 minutes to pitch their presentation, followed by 3 minutes from Q&A from the advisory panel. At the end of the 5 minutes, we will tell you that your 5 minutes is up. We'll have you stop sharing your screen, and then I will be moderating questions and answers from the advisors. For the advisors participating today, you should have received a link from a Google form for you to submit additional feedback for our teams, which we will share with them after today's showcase. At the end of each 5-minute presentation, you will have 3 minutes for Q&A. Please submit your questions to the Q&A bar at the bottom section of your Zoom panel. I will be moderating those questions for 3 minutes, and then we will move on to the next team. So we were going to kick it off today. If James Richards of CFV Labs can share his screen, I'm going to stop sharing mine. James, are you ready to share your screen? Now get ready to time.
Hey, can you guys see me?
Yes.
Cool. Let me figure out how to share my screen here. Can you guys see the presentation?
Don't think you've shared your screen yet.
Not yet. 1 second. There we go.
Great. You may begin.
1 second. So normally it pops up 2 different images. There we go. Okay, so hi, my name is James Richards and I'm an electrical engineer at CFE Labs. I will be presenting my American-made Solar Prize set pitch. This presentation will discuss how we can cut the cost of solar by aiding in the development of new technologies such as power electronics and perovskite solar cells. So how do I advance it? There we go. Back in March, the US Department of Energy made an announcement about the future of clean energy in the US. First, DOE aims to cut the cost of solar energy by 60% within the next 10 years. And second, that it'll spend nearly $128 million over the time to lower costs, improve performance, and accelerate the deployment of solar energy technologies. In recent years, metal halide perovskite solar cells have become a major competitor in the search to lower the levelized cost of electricity of PV systems. There have been concerns about issues which could affect the measurement accuracy and practical applications of these devices, namely the hysteresis, stability, shade tolerance, and possible environmental effects. Thus, it is essential to enable reliability assessment in the pre-commercial stage. The unique properties and poor stability of these technologies create challenges when trying to measure these devices. Perovskite technology is so new that these cells are mostly manufactured in small coupon-sized samples. You can see that in the left picture. Some of the largest samples that we have seen so far are approximately 6 inches by 6 inches. The voltage and current characteristics of these samples are not within the measurement range of modern PV test equipment. Okay, so if they're not within the range of modern PV test equipment because they're so small, now we need to discuss the type of equipment that is needed to test these perovskites. So feedback from national labs such as Sandia and NREL have indicated that these cells need the ability to be held at MPPT, which stands for maximum power point tracking. They also need to have the ability to take an IV curve. And so by coupling IV sweeps, MPPT, and other methods such as constant voltage in one machine, we can overcome these measurement limitations. So CFE Labs is already developing tools to analyze these problems by building diagnostic instrumentation for both indoor and outdoor use in cooperation with the Sandia NREL Perovskite Pack Center. CFE's custom instrumentation can measure up to 16 cells simultaneously, allowing a larger sample size to be tested and improved upon. So you guys can see in the picture here, the lower right image, that is one of the 16 channel units that we just prototyped. Okay. So we can reproduce many emerging perovskite technology workflows with this system. NREL presented a method called Asymptotic Iv Curve. This method looks at each voltage set point and waits for the power to settle to a stable state before the next measurement is taken. This method of measurement is also called stabilized current fixed voltage. This method has been successfully demonstrated and tested on the equipment that we have built. Okay, so developing a physical understanding of the mechanisms governing the operation of perovskite solar cells is much more demanding than for silicon solar cells. In order to design the next generation of power electronics, the industry first needs to characterize the perovskites and perovskite tandems. This will require commercializing our test equipment so we can distribute this technology to the perovskite industry. The plan is to use CFE's commercialized test equipment to develop MPPT algorithms and other perovskite specific features for commercial power electronics, including string and central inverters, microinverters, DC optimizers, and AC modules. The scale of the measurement equipment can be supported by CFE's current infrastructure and staff, which ranges anywhere from $1 to $2 million. The scale of the power electronics market is comparable to the current scale of the PV power electronics market, which is about $19 billion. The target market for this test equipment will include perovskite manufacturers, national labs, and test labs. The perovskite and perovskite tandem markets are in their infancy and product roadmaps are still a bit unclear. CFE will develop power electronics product capability to keep up with the rapidly changing landscape. In the ready round, CFE used the money to build a perovskite characterization system. In the set round, CFE proposes to commercialize the current test equipment. And in the final go round, CFE plans to develop MPPT algorithms and power electronics for inverters. Here's a little bit of a background of our company. So CFE Labs is a US-owned renewable energy test and research laboratory located in Albuquerque, New Mexico. We are known in the industry for our technical expertise and the ability to execute both highly custom and more standard projects in a very timely fashion. We have strong relationships with national labs such as Sandia and NREL, as well as local manufacturers such as Betatron. Betatron is in the process of becoming an American-made network connector, and luckily they're right down the street from us. So CFE has a diverse team with a broad skill set, which will enable us to successfully compete in the American-made Solar Prize. Thank you.
Thank you very much, James. We will now move on to question and answers. The first question is from advisor Joe Barron. Not clear on who your customers will be. Are they cell manufacturers, solar farm operations and maintenance people, research facilities, etc.? Can you talk more about that?
Correct. Yes. So there were different stages, the ready, set, and go. So in the beginning stages, we were looking at test equipment, and that test equipment will be marketed for cell manufacturers and R&D labs such as Sandia and NREL. Once the technology is mature enough, then the goal is to be marketing these technologies or the MPPT algorithms towards inverter manufacturers.
Great. Who are your competitors?
So right now, due to the chip shortage, our competitors are actually Sandia and NREL at the moment.
And what is the current expected market share of perovskite panels in the future expected to be in 5 years and in 10 years?
That's a tough question right now. So perovskites are extremely new to the industry. Perovskites are showing a very promising future relative to silicon. They've increased their efficiency tremendously over the past 5 years. So potentially, if the cost is lowered, it could actually be a competitor to silicon, which is close to anywhere from $20 to $100 billion market.
What is the unique aspect of CFV power electronics and why is it special for perovskite solar cells since MPPT and relevant algorithms are used in the industry already?
Yeah, so what's unique about the power electronics that we're developing is they're compatible with perovskites. And what that means is that, well, so perovskite solar cells do not behave like silicon solar cells. If you would take a standard measurement of a perovskite, it can actually change throughout the day, depending on the light levels, depending on the temperature that it is outside. And so the current MPPT algorithms that are used in silicon are not actually compatible with perovskites. And we are learning that.
Okay, great. For the MPPT algorithm part, where do you plan to embed them? Will you be making controllers yourself or using existing ones from the market?
Yeah, so right now we are planning on designing MPPT power electronics for tandem perovskites. That's where you have a silicon cell and a perovskite cell on top of each other. Now, right now, the tandems are still in their infancy. The cells are about the size of postage stamps. But until then, if perovskite cells become more widely used in industry, the goal is to license MPPT algorithms out to inverter manufacturers.
Great. You claimed that your cost benefit of 60% refers to PV module or a PV cell hardware or the whole cost.
Sorry, one sec.
Oops. I think
go ahead.
I think your time's up for questions, but I will share that question with you after today so that you can get that feedback.
Yep, sounds good.
Thank you very much, CFE Labs. Our next team can share their screens, Origami Solar.
Morning.
Good morning. All right, your 5 minutes. Once you get in presentation mode.
I'd like to take just a second to get it into the proper mode.
Yep, take your time. I think if you go to view.
Yeah, I'm trying to highlight just because I only have one screen. I'm trying to highlight just the part that I want to share.
Okay.
And we did it yesterday and it's not working today. All right, I'm going to have to wing this without reading my materials. So thank you for everybody. Hello, and thank you for everyone to put in all the work and effort to review each of these presentations. Today, I'm going to be presenting about Origami Solar. My name is Eric Hafter, and I'm a founder of the company. The aluminum, in terms of, I'm sorry, I'm just going to do it this way, and I apologize for everybody having to see my thing. PV solar has and continues to revolutionize energy supply around the world, and especially here in the US. Doing so has required innumerable innovations, resulting in drastically lower costs and improved function in almost every area. The metal frame, which wraps the PV laminate to protect it and to facilitate mounting, however, is a standout for lack of innovation or cost reduction. Instead, the industry has relied upon extruded aluminum since its inception over 50 years ago. This continued reliance on aluminum has significant consequences. An oversized greenhouse gas production, resulting in 17 million metric tons of GHG in 2021 alone. Nearly 100% of aluminum module frames are produced in China, and US manufacturers source frames from there. And COVID, war, and other factors have highlighted the long-term risks and challenges of offshore logistics. PV modules need frames to protect and to mount. Origami has designed and engineered a solution to the serious problems associated with continued import and use of manufactured aluminum frames. That is, we make the frame using high-speed roll forming from very thin sheet steel. The expected results? We've engineered a novel and strong frame profile using precision roll forming techniques, which allow us to include 12 bends and hem folds in a space barely 1.5 square inches. Very high strength, a 70% to 90% reduction in greenhouse gas emissions, and supply chain independence using domestic production and manufacturing. We're very excited to let you know that since the ready round, Origami Solar has completed our proof of concept product. Along with our manufacturing partner, we completed the design, engineering, tooling, and even built an actual factory production line. We've fabricated our first articles, manufacturing 600 module frames, which is over 3.6 kilometers of roll formed steel frames. We've installed these frames onto test modules and are proceeding with testing to UL standards and industry benchmark. Our frames are very similar in form factor to aluminum frames. They may be used with existing laminates, are compatible with PV module manufacturing methods and automation. They're being installed using industry methods and hardware. And our frames are coated with a very durable chemistry that delivers corrosion resistance for the life of the module. We've made huge progress since our selection in the ready round. We received our proof of concept frames. We're in significant engagement with multiple North American solar panel manufacturers. We're soliciting input from racking manufacturers to ensure compatibility with their systems. Origami is working directly with utility scale developers who will create demand for steel module frames. Our team is engaging the North American steel ecosystem on multiple levels, including steel producers and roll formers. And we're pleased to have the support for product certification and reliability testing organizations, including Sandia National Labs. We have interacted with customers and potential suppliers extensively and are confident of our business model to license our technology. We have and continue to target customers that make the modules, as well as steel and roll forming companies that see this as an incredible opportunity to return manufacturing jobs and commerce to the US. As part of this, we're currently exploring JV opportunities with steel and roll forming companies. We're starting to fully grasp the enormity of the market and this exciting new opportunity. And as you can see in 2021 production estimates, the steel frame solution for US solar manufacturers would have resulted in 100,000 metric tons of new US steel and roll forming production. Finally, I'm very pleased to let you know that Origami has built an incredible team of full-time employees, along with key consultants and service providers. I'm particularly happy that our team is very stable with no turnover whatsoever, which in these times of unprecedented job change, I consider a personal testament to our company, our product, and our vision. That concludes my presentation, and thank you for attending.
Thank you very much, Eric. We are going to begin your 3 minutes of Q&A. The first question is from Sakshi. Is the cost difference quantified? Existing aluminum and Origami's cell ones?
The historic and very durable cost difference between aluminum and steel is about 3x. Origami frames do use more mass than aluminum, but we have a significant cost advantage on the material cost. We're currently working with multiple suppliers, as well as optimizing our design to continue to try to bring the cost down as low as possible. We're very confident, though, that we're going to be at parity or significantly cheap and working towards significantly lower cost.
Awesome. From advisor Cole Wolfson, could you quantify in dollars what your stated problems mean for your customers? Are their costs higher? Are they losing sales due to lead time?
In terms of logistics, I can give you anecdotal information. A couple of US manufacturers told us that they came right to the brink of stopping their manufacturing due to supply chain problems of getting their aluminum frames from China. As I mentioned, our cost delta, we feel that we're going to be starting off at parity, but then being able to continue to reduce costs as we build manufacturing and continue to optimize our product.
Great. What is your approach to IP?
So we are an IP licensing company. We have currently filed 12 patents. We've done our first international patents, utility patents, both in the United States, India, Europe, and China. We're expanding our patent reach into Latin America, and we will continue filing more patents. As I mentioned, we've now filed 12 and over 400 claims included.
Okay. Why aren't manufacturers using steel for module frames already?
That's a great question. A number of people or groups have tried in the past. It's very difficult because, as you can imagine, when I mentioned that we were packing a lot of folds and bends into a very small area, it's very difficult. We actually did a very wide search to find a roll former that's capable of high precision roll forming. And we're very fortunate. And our first proof of concept proved out our work. And we have actually interfaced with a number of groups and people that have tried in the past who are really impressed that we've been able to crack the code. This has been a goal, I think, for a long time, but it's been very difficult to try to match the precision and durability of aluminum with a product which is better for the environment and we feel will be dramatically lower in cost and has other attributes that steel properties of steel have that aluminum doesn't, primarily with regard to ductility and durability.
Awesome. Thank you very much. That ends the 3 minutes for question and answer.
Thank you.
1 minute pause for advisors to submit their feedback. And the next team to get ready is Solar Culture Hoop House, and I will let you know when to begin.
Okay, I think you want the solar culture screen.
We're not seeing anything shared yet.
Okay.
Solar Culture, are you able to share your screen?
Yes.
Go ahead.
Are you on the right window? This is solar culture, not
Yes, solar culture hoop house.
okay.
Yep, Glenn, if you want to share your screen, that'd be great.
Yeah, I've shared it.
We're not seeing it on our end. So did you hit share screen?
Yes.
The green button in Zoom. Oh, it's coming.
There we go. Okay.
Great. Once you get into presentation mode, we can start your 5 minutes.
Okay, you ready?
begin.
Okay.
Yep.
This is Glenn Allers with Solar Culture. I'd like to talk to you about a solar greenhouse that generates power, saves water, and increases crop yields. The problem we are addressing is the competition between PV development and agricultural land use. The ideal solution is to combine solar with agriculture. The current approach to this is to elevate conventional panels above the crop, allowing for planting below, otherwise called agrivoltaics. Unfortunately, this approach is not being adopted. For the energy developer, it increases costs with little financial gain. Rental income from the farmland below does not justify the added cost of the PV installation. For the farmer, his job is more difficult working around a PV array. So it's a lose-lose situation for the stakeholders. Our solution is to focus on covered agriculture. Covering a crop reduces evaporation and increases water use efficiency by up to 10-fold. It also increases crop yields. Best yet is covered farmland rents for a few $1,000s an acre instead of a few hundred. The main obstacle for the grower is the capital expense. But energy companies are very good at providing capital if there's a power purchase agreement or a lease agreement. So the PV developer is happy with a PPA and rental income. The farmer is happy with higher yields and saving water. It's now a win-win proposition. For this project, we built a demonstration greenhouse for our semi-rigid hoop house solar panels. We modified a 25-foot by 120-foot greenhouse by installing curved hoops and plastic covering. We then mounted our semi-rigid panels to the south side of the hoop house roof. The panels are made of lightweight semi-rigid plastic and are about 3 feet by 6 feet each. Quarter-cut bifacial silicon solar cells are spaced out across the module to allow for flexing without cracking. Rigid aluminum channels are integrated into the mounting to a high-tension wire mesh inside the greenhouse. The panels include a proprietary red luminescent pigment that is known to enhance plant growth. This Ready Award provided the resources to do extensive durability testing on the semi-rigid panels to guarantee that they will survive in the field. Static load tests using sandbags simulated 100-mile-per-hour winds and allowed us to optimize the mounting methods and cell layout to minimize cell cracking. Damage to the modules was monitored with IV and electroluminescence testing to detect cracked cells. After passing laboratory tests, we proceeded with testing in the field for wind and installation procedures. In the end, we were able to build, mount, weather, and remove panels with no damage to the cells and no loss in power output. We would like to cover the full Southwest with a gigawatt of solar hoop houses, but that won't happen soon. The ideal market to focus on is the thousands of food processing plants across the country. These facilities use a lot of electricity for refrigeration and pumping. They're located in agricultural zones, and they pay retail rates for electricity, making them ideal candidates for commercial solar power purchase agreement. The competition is roof-mounted solar, but there's not enough roof on these facilities to supply all their energy needs. Our solution adds value by promoting what is effectively a ground mount solar array. The covered growing space can be leased to local growers who will then provide the crops to the food processing plant. The developer wins with both a PPA and leasing income. The farmer wins with higher yields and less water usage for covered agriculture. The food processor wins with crops and local jobs provided, a win-win-win value. The core business of solar culture is glass PV panels for high-end greenhouses. This semi-rigid product would allow us to expand into providing solar to the broader agriculture community that uses hoop houses. We have a deep understanding of both solar and growing based on our years of working with commercial greenhouse growers. Our greatest strength is that we've built an extensive network of partners in the farming and the solar communities. That makes us uniquely qualified to execute on the next phase of this project, to combine solar with covered agriculture. With that, I thank you for the attention.
Thank you very much, Glenn. We will now move on to question and answers. The first question is from advisor Andrew Shabot. What is the measured percentage of sunlight that reaches the ground for this solution? In some states, they require 50% or more to qualify for incentives.
Yeah, the coverage is about 50% for the cell coverage. And then the red luminescent dye also enhances the red light by about 20%. And the red light is the most important for photosynthesis. So by combining a 50% cell coverage along with enhancement of the red light, we can then compensate for the light loss for the crops below.
Great. What is the percent efficiency of this solution compared to standard PV panels?
The standard test conditions is about 10%, so half the efficiency of a normal panel. However, in the field, we see about a 30% gain due to the bifacial nature of the cells and the red luminescent film. So in the field, we actually get more power output and not less.
Can you provide more detail about how your technology realizes additional value to farmers who already operated covered agriculture operations?
Yeah, so a farmer who already has covered agriculture would then get the power from this. And then that power can be sold either to a local food processing plant or to the utilities. So they would gain the additional revenue of the power. And then the biggest advantage is that they would then get the capital investment to expand upon more covered agriculture. So the real target here are farmers who are not yet using covered agriculture and would like to expand into it, but don't have the capital.
Okay, great. Can you talk more about your team?
Yeah, so right now it's me and one engineer working on this, and we have many partners. Quidon is our greenhouse manufacturing partner. Whiskey Hill Farms is the farm that we work with to grow crops underneath the panels. So we have extensive data on actual organic farming. Our production is done through a company called Oxen Solar. So once we have the prototypes developed here, we then contract out to them for high volume manufacturing. And then finally, we work with companies like D2 Solar that are in the American Made network.
How is the price of electricity cheaper for the buyers who can also go for PPA?
Well, we're targeting the retail people, such as the food processing, and they're paying retail rates for electricity. So that in California, that's about 15 cents per kilowatt hours. And that's a much higher value proposition than, say, utility scale, which locally here is about 6 cents per kilowatt hour.
Okay, and last question. What is the difference between your demonstration and the flexible substrate solar module that are already used in the market?
Our modules have the cells spaced out, so they're semi-transparent, and that allows for a lot of light to come through in a uniform way. What growers really do not want is shading of their crops, non-uniform shading. So you put up a standard flexible module that's fully opaque, it's going to shade the crop down below, and that will slow down the growth, and that will cause problems with the uniformity of the crop. Our panels provide very uniform illumination, and they also provide the red luminescent enhancement to stimulate plant growth. And we've seen upwards of 30% improvement in crop yields underneath our panels. And you can't say that with standard panels.
Okay, great. That ends this Q&A. Thank you very much. Well, actually, there was one last question. Sorry. Scaling prospects outside of California, utility retail prices are different in other states. So what are your scaling prospects outside of California?
That's why we like to focus on the food processing plants, which are located everywhere there's a farm, there's usually a food processing plant, and they pay retail rates. And so that's much more stable. So typically retail rates are 10 cents per kilowatt hour. But you're right, there are some states like Texas where electricity is very cheap, and we have a hard time competing there. These are the utility scale. So again, we focus on the food processing plants to get utility PPAs.
Okay, great. That ends the Q&A. Thank you very much, Glenn. We're going to take 1 minute for the advisors to submit their feedback. And while we wait, can Solar Scotta with Greg Linder, can you please get ready to share your screen? Okay, Greg, we're ready for you. Whenever you
And
start, I'll
can
start
you
your
s-
4 minutes.
You can see my screen?
Yep, we can see your PowerPoint.
Okay, here we go. Thanks everybody for coming along. My name is Greg, and I'm going to talk about our approach to solar data integration. This graph shows the falling cost per kilowatt hour of solar energy over the last decade. Initially, costs fell rapidly. However, for the last 4 years, solar energy has plateaued at around 6.4 cents per kilowatt hour. To achieve DOE's target of 3 cents per kilowatt hour by 2030, we still have to reduce the cost by 50%. These cost savings have been driven primarily in innovations in PV modules and inverters. However, there are many soft costs that can be reduced. SolarSCADA's disruptive technology provides significant savings in these hardware and soft costs. In order to meet the data needs of modern PV facilities, solar data systems require many components requiring expensive integration. These components include met stations for the weather, a central rack with servers and probably an air conditioner, firewalls and IT equipment, interfaces, utility equipment, and so very much more. Additionally, these devices all require individual programming and configuration for each device for every site. This leads to large, complicated, quasi-custom design control cabinets that require substantial cost to design, fabricate, and install. Through research and development and partner collaboration, SolarSCADA has integrated and miniaturized all of that custom hardware into the world's first IEC 617241 compliant mass producer, utility scale, supervisory control, and data acquisition SCADA system targeted specifically for solar. Solar plant developers and O&M providers will buy this product because it's smaller, reduces the risk of install errors, and installs 14 times faster, averaging just 1 day per system install versus 2 weeks or more for our competing systems. This is a 5 megawatt site in Colorado. The SolarSCADA system is installed here at the switchgear. Inside this box is our version 3 equipment and support systems, which we are integrating in our version 4 hardware. Every SolarSCADA system installed gives user access to our software portal for a low-cost subscription fee for the lifetime of the system. This portal integrates real-time data observability through the web or smartphone. SolarSCADA team brings a combined 50 years of experience in electrical engineering, business development, and operations management. Our team manages 3 tiers of partners: foundational design and manufacturing, equipment vendors, and infrastructure support. Our design and manufacturing partners support our software, firmware, electronics, and enclosures. Our equipment vendors supply sensors, cables, and calibration services, and our infrastructure partners support cellular data and cloud hosting services. 3 of our partners are members of the HeroX American-made network. SolarSCADA will use the Solar Prize vouchers for IEC compliance verification using the National Renewable Energy Lab, surge immunity testing via Sandia National Lab, and developing an instrumentation calibration plan for traceability of our instrumentation. SolarSCADA completed our first system in 2018 with our launch customer. By the end of 2019, we had 10 projects and a second customer. By the end of 2020, we had 30 projects, 3 customers, and had gone through 3 hardware revisions based on customer feedback. By 2021, our hardware was installed at 47 projects totaling 37 megawatts and primed for validation and verification made possible by the American-made Solar Prize. Since winning the READY contest, SolarSCADA has added 3 more projects and invested in integrating our version 4 hardware, a prototype which is currently being validated and testing using the money from the SET contest. This will enable us to meet our goals for a commercial scale rollout starting in 2023. This shows the growth of US PV generating capacity since 2008. SCADA equipment costs account for about ½ cent per watt of installed capacity. Changing the vertical scale from gigawatts of PV into millions of dollars gives our possible growth since 2008. The total addressable market was $500 million in 2021, with an available market of $350 million and an attainable market for us of $50 million. Winning the Solar Prize contest will enable SolarSCADA to scale up production and reduce the hardware and soft costs of solar energy in the United States. This will enable market capture of the 50 million obtainable market while simultaneously driving the cost per kilowatt hour down by 10% or more through savings in hardware and labor soft costs. Thank you for your time, and here's a map of our currently operating facilities.
Thank you very much, Greg. We will start question and answers in 1 moment. Your first question is, do you consider DERMS a competitor, or are you a component in a DERMS system?
The DERMS, that largely just depends on the scale of the DERMS. So our system is a SCADA system for solar. We have plugs for BACnet and whatever else you have. So we can integrate with generators and micro hydro and whatever else. So if you have a very complicated DERMS that has lots of different resources and energy management tools in your building, we can plug into that system and interact with that.
Great. Question from Advisor Hans. What are the hurdles that you are facing to scale up?
The single biggest challenge is bankability. The target customers that we need to deal with generally are justifying their spend to investors and utility companies. And Solar SCADA, although we do have presence now in 6 states, we're a very small company without significant financial backing. So despite the technical cost and hardware lead, it's difficult for our customers to justify going with a company that is valued at $0 from the point of view of a commercial standpoint.
Who are your competitors in general?
Also, Energy just got swallowed up by STEM, and they sort of dominate 80% of the type of market we're into. As you go larger, the competitors become the GE of the world that supply, Schneider kind of controls and people that make professional quality SCADA software, and the integrators that put it together. So that's the NorCal Controls of the world. It's those entities.
Okay. Is Solar SCADA's customer market segment geared towards developers and site owners, operators, or only utilities as well? If so, how do you integrate with existing utility back office systems? Also, can you integrate with existing private communications used for other SCADA systems?
So Solar SCADA's customer market is geared toward anybody that needs this system. We have a very retrofittable product, and there's no technical challenges with approaching utilities with our product, aside from the bankability discussed below. Integrating with existing utility is no problem. We support DNP, OPC, IEC 61850. Choose your protocol. We probably have software that supports it because we have very good support in that area. Existing with private communications, yes. We run our own private VPN that we admin as an AT&T IoT partner. So integrating with existing VPNs for other SCADA systems is as simple as either adding their security keys to our system or implementing their firewall equipment if they have a hardware solution.
Great. And last question, do you have direct competition in terms of companies building similar integrated solutions?
So the closest competitors to us are the NXS products and the also Energy/STEM products. But they don't provide the full, it's very expensive to add a KYZ pulse input, for example, to that system because they don't offer it bundled already. So you end up having a PO that's 18 pages long with a bunch of feature ads that just comes with our system, and we're configured in the field by what plugs you use on the front of our product rather than what you've ordered and comes in the box. So there's nobody else that does exactly what we're doing in using microelectronics, circuit boards, to put everything inside of this single device specifically targeted at that IEC specification.
Okay, great. Thank you very much, Greg. Your 3 minutes is up.
Thank you very much.
Okay, we're going to be taking a short break until noon. Please stand up, drink some water, and we'll see you back at noon for the next set of teams. Arcam Technologies, you will be up after the break. Hello, everyone. Welcome back. We are going to start with Team 5, Arcam Technologies with Gabriel. If you are ready to share your screen, we can start your 5 minutes. I see your screen.
Not hearing any audio from you, Gabriel.
Yes, I can't hear you either.
Is that any better?
Much better, yes. Thank you.
All right. Sorry about that. So floating photovoltaics, or FPV, is a really exciting emerging area of solar energy. There's potential in an NREL study, estimated over 2,000 gigawatts potential only in US inland reservoirs under very conservative assumptions. There's about 12 megawatts only in the US right now, but around 2.6 gigawatts have been deployed worldwide. Using these floating PV systems allows project developers to alleviate land use issues, which can help bring floating solar to municipalities and areas where it's not otherwise possible. And in many cases, actually reduce evaporation of reservoirs, which is important for conserving water. One of the key challenges in floating FPV is the development of robust and low-cost mooring and anchoring systems. So this has been a real issue holding back the development of FPV when in terms of causing catastrophic failure of systems, and also taking up a large component of the structural balance of system costs. A lot of the challenges in mooring and anchoring is using kind of outdated technologies. So this is examples of a typical concrete gravity anchor that could be used for these systems. The process overall uses a lot of one-off engineering to understand the loads and design these components, but they eventually come down to being a concrete block that sits on the seabed or bed of the reservoir and uses its weight. So these are very inefficient anchors, and because of that really bulk material, they're expensive to transport and hard to install, needing vessels and cranes that can lift these components. So our solution that we're developing at Arcam is to use 3D concrete printing of anchors and couple that with an overall mooring design that's more efficient. We use 3D concrete printing to accelerate the engineering process by using digital design tools that allow us to rapidly produce anchor designs and print them. And this also allows us to use more material efficient geometries that actually lock into the soil and increase the holding capacity per unit mass compared to a normal concrete block. So during the SET project, we've been conducting customer discovery interviews to learn more about the ecosystem, the emerging ecosystem of FPV in the US. We've interviewed project developers of FPV, like Third Pillar and D3, and understanding their needs. And we've really become aware that this is a rising challenge. And there's a number of applications, such as reservoirs with liners, where there are no existing good alternatives for anchors that are more efficient than concrete blocks. We've spoken with system developers for the equipment and R&D testing partners as well. We've built this parametric design software to produce anchor geometries that are printable. And then we are working on completing a proof of concept print of this anchor geometry that will be done by the end of next week. Enabling on-site 3D concrete printing with mobile robotic systems alleviates the transportation issues and allows us to produce anchor shells that are actually floatable, so we can reduce the need for vessels. Our beachhead market we've identified is really reservoirs with impermeable liners, mainly in California and the Southeast. And then we have a pathway to expanding this to other reservoirs in the US. And then we can really scale these components for the larger loads for offshore systems, US and globally. Our edge is that our company, Jason and I, have over 30 years of experience in energy and cement and concrete R&D. We have a large network of R&D partners and universities, engineering organizations. And we're getting this facility for R&D printing at the Port of LA starting this summer. In the go phase, we're going to refine our anchor prototype designs, perform tests of the anchor embedment, get more detailed evaluations of our product costs, and find a partner for our pilot demonstration. Thank you very much.
Thank you very much. We will take a moment before we start the Q&A. first question is from Andrew. How much variety is expected in concrete anchor designs? Does a design change significantly between soil type?
Yes, so we are kind of investigating this right now. We've seen one of the key aspects is basically how soft the soil is, and the level of penetration that we can expect. So those are the key parameters. So we can either have to thin these skirts.
Sorry, Gabriel, I think you are frozen. Wait, you're moving again. Okay, I think we heard close to the end of that question, so I'll move to the next one. What is the market opportunity? How big of a business can this be?
Yeah, like I said, just in the US alone, there's over 2,000 gigawatts of potential. Speaking to FPV developers, the amount of anchors and project costs for anchors still varies pretty widely, but they need around, typical systems need at least 40 anchors, and they're, say, around a couple $1,000s a piece at the lowest cost end. So that's kind of an indication. We have a huge potential coming up. I can quantify that.
Great. What are the design principles for making project or site-specific efficient anchors?
Yeah, so the design is based on this, the geotechnical interaction and how we can increase the amount of area that increases the friction with the soil. And that really helps, especially for the horizontal loading. So when it's a vertical load, gravity anchors are okay, but conventional blocks only have about 1/3 of their capacity in the horizontal direction. So more efficient, we can produce a lot more efficiency in horizontal loading.
What is your competitive advantage? Is it 3D printing, getting costs down, or is it unique anchor design?
They are both. So the printing aspect, just comparing that to casting, is always going to be a little more expensive. But we are able to save material and actually accelerate the project design and engineering of these very significantly. With this design tool, we can produce the geometry and print it in a matter of a day and produce anchors like these multiple within an hour shift, 8-hour shift. So we can really accelerate the whole process from engineering to fabrication compared to making customized forms.
We can take one more question. What are the cost implications of using 3D printing tech compared to the traditional concrete block design methods? Any ballpark number?
Right, so we're still assessing that because we have to factor in the overall project costs, including transportation and install. So just looking at the materials, this is going to be more expensive, but we're evaluating that numbers in a full comparison of the project lifecycle.
Great, thank you very much. That's the end of your question and answer period. Our next team is Resilient. We're going to take one moment, but if Resilient Energy and Infrastructure, Ludo and Manoj, if you can get ready to share your screen, that would be great.
Sure.
Okay, you can begin.
Everybody can hear me?
Yep, we can hear you.
Good. Hello from Nashville, Tennessee. I am Ludo Roche, partner at Resilient Energy and Infrastructure. Over the next 5 minutes, I'll go over the progress we've made on our rapid deployment hybrid microgrid since winning the ready phase of the American Made Challenge. Natural catastrophe have severely impacted the grid infrastructure over the last few years, costing billions of dollars in recovery efforts and burning millions of gallons of fuels. Yet, today's go-to solutions for temporary power are diesel generators. While effective, they're expensive and have a negative impact on the environment. They create logistic dilemmas and are linked to death and injuries during resupplies. The decision to use a diesel generator when the grid is not present or no longer available is primarily driven by the lack of scalable and truly transportable solar PV product on the market. REI focuses on resiliency solutions where high reliability creates high value add for the client. With that in mind, we developed RDHM, or Rapid Deployment Hybrid Microgrid, a scalable plug-and-play solar PV product leveraging ExoSolar. RDHM is designed to reduce or eliminate the usage of diesel generators. RDHM have been designed around ExoSolar, an innovative proprietary on-wheel accordion-style racking system that speeds up the installation, deployment, and storage of solar panels. RDHM and ExoSolar differentiate themselves from all other solar solutions on the market by not having to be physically attached to the container or trailer with the simplest and fastest deployable solar PV array. This time-lapse video was taken in Puerto Rico, where we delivered 7 40-foot containers of ExoSolar, total of 320 kilowatt peak. The units will be commissioned to the client's BESS in a couple of months. Winning the ready stage of the American-made challenge has provided further credibility to our RDHM concept. We enhanced our supply chain and attracted Enphase Energy as a collaborator for our showcase. Their team says that our combined solution could be revolutionary. Our first implementation with Enphase is a home essential backup system with a 20-foot container. The showcase functions as a grid supplement or totally off-grid as needed, providing sunlight backup during the day or battery backup. Winning the set phase of the challenge would allow us to further enhance this showcase with Enphase and prepare a full RDHM for field testing. During the set phase, we have also made much progress with our customer discovery and spoke with over 40 stakeholders and continue to do so every day. The results speak for themselves. We have received 2 letters of support. One of them is from a subject matter expert at Picatinny Arsenal with the Department of Army, who sees a potential integration and use of the RDHM for the US Army and plans to support the development of this technology for emergency management. The second is from a senior scientist at Booz Allen Hamilton, who sees the integration of RDHM as a technology to provide power to defense programs. REI is also in conversation under NDA with a strong channel partner and studying a project for one of their clients. NOAA, which only tracked disaster that causes at least $1 billion in damages, reported that natural disasters have cost the US over $2.1 trillion since 1980, estimated $145 billion in 2021 alone. However, finding details on expenditure associated with diesel fuel and generators proved challenging. Quoting the Moving Energy Initiative research paper from 2018, in the absence of more reliable data from a greater number of agencies, any estimates of energy costs associated with complex humanitarian situations or of the potential to affect savings will be highly flawed. During our customer discovery process, however, we spoke with a FEMA contractor who confirmed to us that during the response of the Puerto Rico Hurricane Maria, FEMA spent $2 billion with their company alone in diesel generator and diesel fuel. REI's serviceable obtainable market is difficult to quantify accurately. However, based on our current progress, we expect to sell 10 to 15 systems with revenues between 1.3 and 2.5 million over the next 12 to 18 months. Paul and I joined forces as a result of Hurricane Maria and our common vision for emergency response and what turned out to become RDHM. Dr. Manoj, an associate professor at Stony Brook, complemented our team as our defense advisor. Since the go phase, we co-located our supply site with GPS sources. Brent and his business partner, Jeremy, are not only friends, but supporters of REI and successful entrepreneurs themselves. We have been able to lean on their manufacturing experience and local contact. We also strengthened our board, providing complementary expertise to our team. And without forgetting, of course, special thanks to the Network of American Made Challenge. From the CMU team and Ben Colgrove to the American Made Network connectors, Dick Mephister-Krohn, and we've also identified NREL for our voucher partner. Shall we move to the set phase? Thanks for your attention and looking forward to your questions.
Thank you, Ludo. We'll take one moment and then we'll start the Q&A. Your first question is from Cole. Do you have any IP?
We are in the process of determining that. We are primarily a system integrator. We have IPs on the racking system, which I co-founded a company that initially started that.
Great. From Andrew, will you have different solutions for different module sizes beyond 305 watt modules?
Yes, so it's a great question, actually. Thank you for asking it. I didn't have time to put it in the video. We have worked on during that go and set phase of the process to increase the size of the racking system to accommodate modules of up to 400 watts, which usually is the limit for the 120 cell modules. And we've earlier on did a lot of studies. Going to 72 cell module would significantly increase the weight of the units and diminish the transportability and increase the cost of manufacturing by having to use the side of the container as opposed to the existing double doors. So yes.
Great.
I hope that answers the question.
From Sakshi, how big a site can this system serve? For example, kilowatt or megawatt scale load. Can these modules be connected in series to serve larger site loads?
Yes. So the Puerto Rico project that will be connecting to the client's BESS is actually 320 kilowatt. It's going to be 175 exosolar units. It's over 1,050 PV modules are going to be daisy chain. The client is a manufacturing site, and they just want the ability, if there is a hurricane coming, to have our team stow the solar panels away in a container before the hurricane and redeploy them afterwards. So I think, we're still studying that, but I think the sweet spot is anything, below 500 kilowatt, but we can absolutely get to a megawatt. There is no really limit on the size of the system.
Who are your competitors?
I would say Acro Energy is a great company. They have, which I think is probably the closest competitor that we have. Their system is based on a 72 cell module, so requires a little bit more, I would say, machineries to deploy. We focus on being able to have the system deployed with two people, as opposed to a truck and some railing and some siding prep. Box Power is a great company as well. They have a system attached to the container, but they've done a good work. And then you have the trailer based system, which are great, but small scales as well. So I would think that's where I would see our competition, short of a diesel generator.
One last question. How much real estate do you need?
Depends on the size of the project. We think not more than a traditional solar installation would take. The system is designed in a way that we fit as close as possible to the PV system. So if you have a 10 kilowatt system, so it's the same size as a traditional solar installation. If you have a 320 kilowatt, it's much larger, but nothing more than a traditional size of a solar system. The unit itself is 24 feet long by almost 8 feet wide.
Okay, great. Thank you very much. That's the end of the question and answer. We'll take a moment. And if Texas Solar can share your screen and get ready, that would be great. Okay, Texas Solar, please begin.
All right, I'm Samuel Truth Seeker, the CEO of Texas Solar. And for the 5-minute, I'm going to show our 5-minute presentation for submittal for the set round. So here we go.
The problem with residential solar is its high cost. It's twice as expensive as commercial rooftop solar and 3 times as expensive as ground mount solar. The reason residential solar is so expensive is because of the complexity of the products. This complexity drives inefficiencies throughout the organization, including sales, engineering, design, operations, and installation, requiring extensive operational and field resources, which our market research shows drives up the cost of solar by 55 cents per watt. Solvari SR eliminates the product complexity problem and provides the ultimate simplified solution that drives down cost of operation for all aspects of the business. The result eliminates the cost premium to the homeowner while increasing profits for the solar installer. The complexity of current technologies become apparent when you look at the numbers. A solar installer needs to determine, order, and ship the right number of 12 different SKUs for any particular array layout and deliver those units to the job site. From those, the installation team must install up to 550 individual components using 6 to 12 tools. This entire process is time-consuming and requires specialized labor. On the other hand, the Solvari SR solar modules are pre-engineered to include all components necessary to build the array. This single SKU product requires no additional components to install, no matter the complexity of the array, requires a single tool, and is extremely fast to install by even the most unskilled labor. The lack of technological innovations that address the complexity issue has resulted in the cost of residential solar remaining stubbornly flat for the last 6 years. Solvari SR's tectonic shift in simplicity breaks this trend, bringing the cost down by as much as 20%. The Solvari SR module is patent protected and will be assembled by Texas Solar. At the core of the technology are 6 mounts adhered to the perimeter of a standard frameless solar module. The mount assemblies, which perform the key functions of the product, consist of several polymeric components produced by Texas Solar, along with commercially available flashing tape and mounting hardware. The frameless solar module will be supplied through strategic partnerships with solar panel manufacturers such as Solaria. Adhered to the backside of the Solvari module are the integrated power electronics, cabling, and wire management. Solvari SR is easy to handle and simple to install. Just lift it to the roof and screw it down. There is no hassle and no fuss. By controlling all components that go into Solvari SR, as well as the assembly, Texas Solar reduces the risk on unsophisticated smaller installers by providing pre-specified components that are tested and warranted to last 25 years in even the most brutal rooftop environments. Due to the complexity of residential solar, almost all solar installers today are specialty contractors focused only on selling and installing solar, and they only sell to their customers once. In the industry, we call this one and done. This one-time sale model makes finding new customers expensive. For this reason, national installers have the highest cost of sales overhead. For local installers who have a presence in the community and receive referrals, the cost of sales overhead is $6,000 less, but their operational costs are higher. By slashing those costs, Solvari SR enables them to compete more successfully against national installers, resulting in lower cost of solar to the homeowner.
With the Solvari SR, I can practically eliminate the operations and logistics portion of my business, especially now where we have this huge labor shortage. I can now go find unskilled labor and quickly train them on the install portion of this one SKU product. For us, this technology is a game changer, and it will give us a competitive advantage in the marketplace by allowing us to deliver a solar product at a lower cost, while we increase profits. It's a win-win.
The operational simplicity of Solvari not only makes existing solar installers more competitive, it makes solar accessible to traditional trades who have been closed out of solar due to its complexity. These businesses provide services to homeowners on a daily basis, and as trusted advisors, they are positioned to engage these customers about going solar. More importantly, these new solar installers can leverage their historical customer list to sell Solvari SR, practically eliminating sales overhead. The combination of trust and lower cost will increase solar penetration in the residential market across the U.S. Home contractors agree with these findings and have provided letters of commitment and support to further develop and, when available, purchase the technology. The residential solar market is roughly 3 gigawatts in size. Solvari SR installs on asphalt shingles, which represent 75% of all roofs in the U.S. Of the 2.25 available gigawatts, Solvari has already secured a pipeline of over 100 megawatts since the beginning of the set stage of the American-made Solar Challenge. We are targeting 300 megawatts of sale commitments by product launch in Q1 2023. During the set stage, we created a fully functional prototype and retired key risk through computer modeling, waterproof testing, mechanical load testing, and material validation activities. Texas Solar has a long track record of developing new and novel products for solar companies. Our team of engineers are solar product experts with collectively over 90 years of solar experience. That experience, coupled with years of feedback from installers, has guided the design and development of Solvari SR. In addition, with the support of the American-Made Challenge Ready Award, we have expanded the team to include an additional engineer and a high-power CRO with extensive solar channel and sales experience. Solvari SR is also being supported by a high-powered advisory team, consisting of solar experts, industry veterans, and business leaders.
All right. Any questions?
Great. In 1 second, we will move to question and answer. Your first question is, how many letters of commitments do you have from installers at this time? In what regional markets?
We have 3 letters of commitment, and one is, let's see, California, Arizona, and I'm not sure of the full range of one of the larger installers that we have letter of support from. So it might be larger than that area. Karen would know more. If you can jump in for a second, Karen.
Yes, letters of support for their national. They have national footprint, not in every state, but probably in 6 or 7 states. Yeah, from Florida to California.
Can you clarify the relationship between Solvari and Texas Solar?
Yeah, so Solvari is our product. Texas Solar is a engineering firm, and we specialize in developing products for solar product manufacturers. And then this is a product that we've been developing and we're planning on moving forward with.
Great. Does your design provide additional benefits in terms of durability or performance?
No, we match current durability and performance. Our performance as far as energy output, although we might run a little bit cooler because we don't have the frame, which will promote more airflow on the backside of the PV panel, which could reduce the temperatures and provide more power output. But our main performance enhancements are in installation time and simplicity for all the back office organizational aspects that currently need to support solar installs.
Great. How much cost savings can a customer expect?
Well, if we look at just the customer acquisition costs, we're looking at $6,000 to $7,000 to $8,000 to reduce the cost of their solar system, because those customer acquisition costs are transferred to the homeowner during the sale of the product. And then there's other cost savings due to the simplification of the back office resources. So this allows smaller organizations to not have to manage a whole bunch of SKUs. They actually wouldn't even need to hire a operations person that usually manages that. So that whole position would disappear. And also they wouldn't need as skilled labor, nor as many folks at the job site. So we can reduce labor costs in the field as well. And this has been shown to be true already with the cost differences between smaller installers and larger installers. The smaller installers, where they have challenges traditionally, is that they have a higher operational costs on the back end to support the complexity of the product, where larger installers, they have systems and processes, and one operations person can handle a lot of jobs. So it's stacked against the smaller installers on the operational costs, but Solvari tackles that directly, simplifying it so much that they can remove all of those processes from their current overhead.
Great. That's the end of your question and answer time. Thank you very much.
Great. Thank you.
We are now, thank you very much to all of the 7 teams who presented during the first half of today's showcase. We are now going to be taking a lunch break. I realize depending on which time zone you're in, this might be more like an early morning break, but we're still taking a break. We will return at 1:10 p.m. The first team at 1:10 will be Soul Activator, George Wu. I also want to remind everyone that from 3 to 3:30 p.m. today, Eastern Time, we're going to have an advisory panel discussion. You will be able to just stay on this Zoom webinar to be able to watch that, so you don't need to click any other links. But to join our Energy Week virtual networking mixer, which is taking place today after the advisory panel discussion from 3:30 to 5 p.m., you will need to register on the Remo platform. You can either do that on the Carnegie Mellon University Energy Week website, or you can use the QR code that you are seeing now on your screen to sign up. We very much hope that everyone will be able to attend the networking event. There will be industry experts, investors, and other competitors from today's showcase and other showcases. And we really hope that all of you are able to attend. So thank you very much, and we will see you back at 1:10.
Good afternoon, everyone. We're going to get restarted this afternoon. So this is the second half of our of the hardware pitches. So we have more pitches to come this afternoon. I want to start by thanking not only the team at Carnegie Mellon University, Kristen and Caitlin, who you have met, but I also want to thank Sarah Gomash and the team at NREL for this opportunity to participate as a power connector. We've been a power connector at the Scott Institute since 2018. So I'm going to quickly introduce our advisory panel for session 2 this afternoon. And then I'm going to pass it back over to Caitlin to go through some of the rules for those of you who are just joining us this afternoon. And I know that we have quite a few people on the line. Very glad to have you here. By the way, I don't want to forget, after these sessions at 3 o'clock, we will have a panel of experts. Some of them are a part of this session, but they've been participating throughout the week. So they're going to give us some of their thoughts and insights, followed by a networking event, which has about 150 people registered. So we're excited to have that group come together to meet with investors. So without further ado, I want to thank our advisory panel for this afternoon, who will be providing guidance and notes to these teams. So we have Joe Barron with Mitsubishi Electric Power Products, Jing Lyon from Bright Energy Innovators in Ohio, Josh Beck with BCI Technologies Investments, Don Morrison with Blue Tree Capital, Bruce Gephardt with Pathfinder Capital Advisors, LLC, Jennifer Merzlak with PSG Energy Group, a CMU alum, Becca Gillespie with Duquesne Light, William Sepon, who's with Essential Utilities, Faith Kellnoffer, who is with Greentown Labs, and Dror Yaron with 412 by 972. So with that, Caitlin, I'm going to pass it over to you, and thank you all for participating today, for being advisors, and for being in our audience.
Hello, everyone. I just want to review for the competitors and presenters today. You'll have 5 minutes for your pitch presentation, followed by 3 minutes for Q&A from the advisory panel. I will be moderating those questions, and so I'll let you know when that time period starts. We will start the 5 minutes when you begin your presentation. So once your screen is shared, I will be able to say your 5 minutes begins now. For the advisors, you will have 3 minutes after the presentations for Q&A and to record your feedback in the Google form, which we will be sharing after the showcase with each of the teams. When you are ready to ask questions, please submit them in the Q&A feature on the lower Zoom panel, and I will be moderating them aloud to the teams. This is the order of the teams for today for the second half. Soul Activator is going to be the first team. So George Wu, if you are ready, we will have you share your screen and we will begin your 5 minutes.
Thank you, Caitlin. Let me share my presentation. Hi, my name is George Wu, and I lead the Soul Activator team. We're developing an economical solar backup power solution. Our target problem is the increasing trend of blackouts, where millions of people now need backup power solutions, including home solar owners, as virtually all home solar systems don't work in blackouts. And the conventional home battery solutions are so complex and expensive, few can justify them. Instead, generators remain the most common solution with unsustainable pollution. home solar owners want a better solution. We believe Solar Activator is the most economical solution for home solar backup power. In a blackout, Solar Activator works with an economical on-demand power source, such as a generator, a power station, or an EV, and a power reserve to provide the missing grid functionality to enable solar power within minutes. The result is an economical solution with a cost down to 10% of a home battery. That also minimizes pollution and enables sustained clean backup power with EV power integration and adaptive charging. Since the ready stage, we have been working hard on power scaling and integration. Over the past 6 months, we have successfully designed, simulated, tested, and combined all the key technologies in a working proof of concept. Next, let's see a few generator demo highlights. Here's a setup. We now have a proof of concept that can comfortably handle more than 2,000 watts of solar power with stable control of loads and with nearly 90% reduction in generator pollution. For even cleaner backup power, the proof of concept can now support EV power integration with adaptive charging. We have successfully tested adaptive charging under various load and power conditions, as well as verified robust transient control, even under aggressive loading conditions. Solar Activator's affordable cost is a key advantage over other solutions. In addition, unlike home battery, Solar Activator does not require complex installation and slow approval times. Compared to sunlight-only solutions, Solar Activator provides stable backup power day and night, rain or shine. And with EV power integration, Solar Activator can provide sustained clean backup power for even the longest blackouts. In parallel with the development work, we have conducted market research and customer discovery. Research shows up to half of home solar owners could be interested in Solar Activator. We plan to prioritize California and Texas as they have experienced serious blackout impact and represent over half of the new and existing installs. Discussions with solar installers and electricians have confirmed online channels as well as installers could serve existing customers and owners. On the other hand, home builders in areas with solar mandate could better serve new owners. Lastly, well, we have also found some great customer trial interest. Perhaps more satisfying is the unexpected gratitude we have received. Our progress so far has been made possible by a great team with decades of developing high-tech solutions and building entrepreneurial businesses. Thanks to the Solar Prize, we were able to expand resources to accelerate the proof of concept development. Beyond our team, we have built relationships with solar installers, EV solution providers, and home builders. In particular, we're excited about KB Home, a leading home builder that intends to deploy Solar Activator for trial. In addition, we're working with American-made network members for testing and collaboration with organizations in their networks. Winning the Solar Prize will greatly accelerate the development and testing and manufacturing of MVP prototypes for trial customers and help us add resources for business development. Thank you.
Thank you very much, George. In 1 minute, we will start the question and answers. Hello, Advisors, if you can submit your questions in the Q&A feature at the bottom of the Zoom window, we can begin the question and answers. The first question is, who is your direct competitor? Is your system able to provide power supply overnight with that low cost? And is the capacity of your system at $1,500, which will be much smaller than Powerwall, correct?
Yeah, so the power capacity, yes, the comparison is at 2 kilowatt as the entry level system, which is what we found is what the minimal required capacity for most of the home solar owners that want a backup power solution. So that's our target initially, and that gives everyone a low cost of entry. As far as overnight power, yes, we can, right? So the idea is that we maximize solar power usage during the day, certainly, and then backfill additional power from the on-demand power source as needed.
Great. Becca says, I think the problem statement is dead on and meets a real customer need. However, I'd love to hear more about how this is getting in front of customers on an ongoing basis to confirm or deny your assumption about what they want, need, or can use.
Yeah, so we have started reaching out to home solar owners to talk to them. We've gone to some events as well as our own outreach to interview them and understand what they have, reasons why they don't use home batteries, which we explained, and what they see would be a minimal viable product that they could use for their needs.
Great. Can you clarify how your product works for consumers without electric cars?
Yeah, so it was pretty quick, but yeah, we can support generators or portable power stations or an EV as the on-demand power source.
How do you anticipate to mitigate supply chain risk issues to bring your solution to market?
Yeah, I think we are planning ahead as far as we can. So that's where, and when we get to actual manufacturing, additional funding would be helpful. That will allow us to try to get ahead of lead time. But we're also making some alternative design choices for some components in case we can't get the necessary components in time.
How do you plan to use the funds if you make it to the next round?
So the main thing is try to accelerate really manufacturing of the initial MVP prototypes that will go to trial customers as well as go into compliance testing. And then also we want to add some business development resources to start more focused efforts for partner and channel development as well as initial sale.
Great, thank you very much. I just want to let the advisors know that any questions that we don't get to will be shared with the teams after this showcase. So thank you very much, George. We will now have 1 minute while Portable Solar Dennis gets his screen ready to share. Thank you very much.
Everyone see that?
Yes, we can. If you want to put it in presentation mode.
I'm good like it is.
We will be ready to begin.
Great. Thank you, everybody. I'm Dennis Nickerson, founder and CEO of Portable Solar. rural Americans spend about twice as much of their income on energy than the rest of the US. They tend to live in smaller homes and have lower incomes. So a 2 to 3 kilowatt photovoltaic system would be the right size, except there's a perverse pricing dynamic in residential solar in which smaller systems are priced at much higher dollars per watt because of the fixed costs embedded in the solar installer's business model. Hardware has become relatively cheap, but soft costs can be as high as 80% of total costs for a 2 kilowatt rooftop PV. For the past 11 weeks, we've been developing a solar PV awning for factory-built homes. We'll provide the factory with almost everything pre-assembled: the solar panels, microinverters, cables, and mounting structure. These pre-assembled cartridges, as we call them, come in 2-panel and 3-panel sizes and get shipped on a flatbed to the factory and can be attached to the wall studs either on the factory floor or at the job site. Manufactured homes make up about 10% of all new single-family homes in the US, about 100,000 units each year. About 22 million Americans live in factory-built housing, which skews about 2/3 rural. Of course, once we have a solution for new homes, we'd like to develop a retrofit product for the 7 million or so existing manufactured homes. While we've only been working on the solar awning for less than 3 months, we've actually been around for a couple of years developing a ground-based PV mounting system that anyone can assemble, fill with water as ballast, and call an electrician to connect it to the house. Since our initial product receives National Science Foundation funding, we can't combine it with DOE funding, so that's why we're starting fresh with our solar awning product. Both products, though, share this in common. They do away with the need for a solar installation company, and with it, a significant portion of the soft costs. Here's what that might look like. A 2.2 kilowatt system costing the resident $2 a watt, fully installed, with a 15-year loan financed 100% at 4.5% interest, would be cash flow positive from day one. That assumes no ITC, no rebates, no incentives at all. I've surrounded myself with solar industry engineers, entrepreneurs who have co-founded 7 startups, and product management experts. For the solar awning project, I've partnered with Texas Solar, which has led over 30 new product development efforts just in the solar industry, plus NTA, which is the largest of 5 companies hired by HUD to inspect and certify manufactured home plants. NT oversees 63 of them. HUD has complete jurisdiction over manufactured homes, meaning if our solar awning becomes HUD compliant, then it is considered approved for 10% of all new homes in the US each year. That's why our efforts over the past 11 weeks have been about, first, getting the engineering drawings approved by a structural engineer and aligned with the HUD code, which we've done, and more recently, lining up customer discovery interviews. In the set round, we'll build several prototypes of 2-panel and 3-panel cartridges and pilot them at one or more of the large builders, but also medium-sized ones as well. We'll conduct wind testing at NREL, plus NTA has signed up as a connector since they also have wind testing facilities. And we'll continue with customer discovery, both at the factories, plus the end users, and also bring on engineers to ramp up our activities. Thank you.
Thank you very much, Dennis. We'll wait a few moments to begin the question and answers.
Sure.
Okay, the first question is, who are your competitors and what is your advantage?
We've had numbers of conversations with the engineers at the leading home builders, and they've experimented with solar. They've experimented with rooftop solar in the factories, and they've all been unsatisfied to date. And so it's really not taken hold yet. Part of it, I think, the feedback we've gotten is that they're very concerned about water intrusion. And so they've kind of been interested in something that avoids the roof and goes fixes to the wall studs. But also they've partnered up with solar companies that have basically wanted to try to replicate the activities that take place at the job site to the factory floor. And it's been very disruptive to plant operations. So nobody's really cracked the code yet. The natural users of this, our customers would be the builders for the OEM product. But they haven't been able to really integrate a traditional rooftop PV system into their plant operations yet.
Okay, what is the anticipated cost for customers?
So the number I gave a few slides back was about $2 a watt installed, and I'll say that's a fairly good guesstimate at this point. Installed meaning there's a portion to cover hardware profit for both us as well as the builder, as well as the electrical installation piece. Which, by the way, that last piece is the wiring is mostly done at the factory when the walls are open, so it's pretty straightforward.
What utility rate did you assume for cash flow payback?
12 cents.
What have been the end use customers' reactions so far? How do you leverage them to iterate your product?
Right. So we haven't spoken to manufactured home residents yet, but that'll be part of kind of the next phase, as well as, and this is kind of an important piece of the customer discovery, is also talk to the retailers, because some of them are, there are over 3,000 retailers that specialize in selling manufactured homes in the US. Some of them are kind of captive retailers that are owned by the large builders, but many of them are independent, and they're sales organizations. So they have quite a bit of say over the end users thinking. And so we'll be getting more feedback from them in the next phase.
And the last question, how does this solution mitigate the systemic module microfractures that result from prefab shipping of modules as you propose?
Right. So part of the wind testing will incorporate the scenario in which the awning actually gets shipped on the highway with the house. It obviously wouldn't be shipped in the extended position. It would be shipped flush to the wall, and we've engineered our system so that it's a secure connection that's flush to the wall. But nevertheless, you're talking about, potentially going 70 miles an hour down the highway. We'll have deflectors and wind deflectors and whatnot. But we want to be able to run that scenario in a wind tunnel to make predictions around things like micro cracking. And there may be situations where it justifies, rather than actually having it installed in the factory, to actually have it installed at the job site, and in which case it would travel inside the house and not be subject to those forces.
Okay, great. That is our last question. Thank you very much, Dennis.
Thank you.
We'll now have MSU Water and Energy Group. Andre, if you can get ready to share your screen and video.
Can you hear me?
Yes, we can.
Okay, good afternoon, everyone. Should I start?
Yes, you may begin.
Okay, so my name is Andre, and I would like to present our submission for the Solar Prize, which is titled Integrated Greenhouse for Food and Water Production. So this is part of our effort at Michigan State Universities, and the WEIR group is a spin-off of our research effort. And this is presented along with Shu Tan and James Klausner. What we're doing here is that we're developing advanced low-cost solar water heater solar water treatment systems integrated with greenhouses for water production, for food production, I'm sorry. And what you see on the left-hand side here, this would be, for example, a large backyard greenhouses that could be mounted with a solar panel, or we're also targeting commercial greenhouses, such as shown on the right-hand side. So this is a generic picture that demonstrates here some crop growing on these large greenhouses. So the challenge that we're addressing, or the problem we're addressing, is that the worsening scenario of water and food production around the world. So what we have on the top left here, this is the amount of sunlight needed in terms of daily light integral for growing crop. We can see on the column here on the left, lettuce, strawberries, cucumbers, and tomatoes. This is the minimum amount of light required, and this is the optimum. And if we compare this with this map here provided, if we focus just on the US, we can see that the Southwest United States, for example, provide plenty of light needed for these crops, even during the winter, and there's a surfeit of sunlight available in the summertime. And we have this table here on the left-hand side. And these arid regions around the US also typically correlate with high solar intensity typically. And then also there's often a significant resource of compromised water, such as produced water, which is associated with oil and gas exploration or exploitation, or for example, it could just be brine water deep underground with very high salt concentration, which are difficult to treat using any kind of traditional RO system. So one possible solution with these problems of having, trying to clean up this water and grow crops would be to develop these advanced greenhouses for extreme environments. And we're proposing two systems, as I mentioned. One is a transparent flat solar panel heater that mounts as a rooftop, for example, combined with a so-called humidification, dehumidification water treatment system that we've developed in the lab. The solar panel can transmit most of the light needed for plant growth. It absorbs the infrared range, which is about 40% of the solar spectrum. And then this provides the heat needed to treat the water by heating the air and heating the water. It reduces also the cooling load for the greenhouse and provides shading at the same times. And then the HDH system provides the essentially the water for growing crops. And we've can meet in the Southwest, we can meet all the water needs for leafy crops such as lettuces and provide partial water for crops like tomatoes, for example. And this provides a very low cost water treatment systems compared to our systems. I just want to mention that the commercial greenhouses market around the world is about $30 billion. Approximately today is expected to grow significantly over the last 5 years by different forecasts. So what we've done over the last several months is that we've tested a solar panel shown right here on the bottom left with the IR cutoff film. And then we can produce water temperatures about 60 degrees C. And this can be used in combination with our HDH system to produce about 70 liters of water per day. So which is enough for growing lettuce, for example. If we had a 25 square meter solar panel, the one shown here is 3 square meters. And we have validated this model with a model. And so we're confident this can scale up very well. Right now, we're using novel design approaches. We're looking at how windows are designed to frame this, whether to frame this in wood, we can frame this in aluminum frames, and to increase the stiffness of that. These are the current HDH system we tested in the lab. So we have tested several configurations. This is the cross-flow system shown in the lab. This is the counterflow systems. And we have developed mathematical models to predict the performance and optimization of these systems based on different pack beds. This allows us to treat all sorts of compromised waters from produced waters, which is very difficult to treat, seawater, groundwater with high salt contents. Fouling is not an issue, or the pack bed shown here, which is used to increase contact between water and air, can be shaken off or just replaced at low cost. And it can also use for desiccation in humid regions. So this is more pictures of our system, the counterflow system. This is a new compact wall-mounted system for humidification, dehumidification system that we're developing also. So I just want to mention that. And this is another bigger picture of the cross-flow system. So the proposed system that we're looking at right now would be to have a Windows-like solar heating system that is partially transparent, mounted with an IR cutoff film to heat up the water and let some light go through for plant growth. And then use the solar energy captured by the solar panels for preheating the water and the air for this HDH systems. The benefits is that it's a very low cost especially the HDS system is extremely low cost. We have more control on the environment in the greenhouse, and that can be used for treating compromised waters. And the power required is minimal, so just a few fans for moving the air around. The drawback are that the one with the drawback is that more maintenance is required and more control systems are required for the systems.
Hello, Andre.
Yep.
You're at your 5 minutes. So
Yep. Okay, I'm
any
done.
questions that people have, they can ask in the Q&A. So we'll take 1 moment for the advisors to submit their questions and answers. Well, their questions, and then we'll answer them with Andre. Advisors, as you're ready, if you can submit your questions. Oh, great. Here's the first question. What maintenance is required? What does that involve?
So the maintenance required would be simply removing the pack bed periodically to remove the deposits on the salt. For example, salts could be deposited. The cost of the system would be similar to, I'm sorry, so that would be the first question.
Yes. The first question was, how do you maintain the system and what are the costs for that?
Yeah, so just the pack bed is the main issue. So we need to change it periodically as we have salt deposits forming on the porous media.
What is the cost of your system?
The cost for the HDS system, it's about just a few $100s. It's simply a simple plastic pipings and some fans. And then for the solar panel, it's more significant. It's like a large window, so it's probably $2,000 to $3,000 approximately right now.
Have you identified your target market?
Yeah, we do. We have we've started customer discovery, and we have identified a possible customer actually out of the country, which an urgent need to growing for treating water and reducing the solar load, and they also have a need for dehumidification in the Middle East. So we have already found customers with a need for these kind of solar-based systems.
Is water purification a current activity at a lot of greenhouses or a future anticipated need?
No, as far as I know, this is the first time I've seen a proposal where we are discussing integrating greenhouses with water purification in one single system.
Have you assessed utilizing this as a bolt-on solution for blue hydrogen production?
No, we have not looked at this.
Will servicing the system be safe if working with produced water?
That's a good question. So produced water can be varies from site to site and over time. I guess it would be the produced water would need to be to provide some certification of what's available, because produced water can have radioactive material, for example. And the content varies dramatically from site to site. So my question is that it depends.
Okay, great.
My answer depends. Yeah, sorry.
Thank you very much, Andre. That's the last question. We will now have Anar Solar share their screen and prepare to present. Okay, Scott, we can see your presentation. We did a second. There you go. Yep, there's your presentation. When you're ready, you can begin. I don't see your video yet.
Okay, can you hear me?
Yes, we can hear you. Can you go back to your presentation?
Yes, I can.
Okay, great.
Sorry about this.
No problem.
And hopefully you can see it and hear me.
Yep, go ahead.
Wonderful. Well, thank you very much. My name is Scott Kavanaugh, and I'm the Vice President of Marketing Operations for a company called NR Solar. We're based in Derry, New Hampshire. And I'd like to show you today or talk to you about our product offering and our value proposition, which is how we optimize landfill solar power production and developer return on investment. The problem that we're solving is that landfills are very popular sites for solar development these days because of the size of the area located. Obviously, the more size you have or the space available, the more power you can generate. But also, it gives a new use to previously unusable space. So we're through solar development, we're turning a cost center into a profit center for both the municipality or the site owner and the developer. With traditional methods of placing solar on landfills, there are some issues because of the nature of the ballast system. Typically, traditional ballast systems use concrete blocks as ballast. And that means they can only be used on the flattest surfaces of a landfill. In this example on the left, you can see how this is obviously from looking down on a landfill. You can see the solar arrays are on the top, which is the flattest section, and also at the bottom where obviously it's flat. That area around the middle is the slope surfaces that cannot be used. The reason being the concrete blocks will slide due to gravity. One of the fundamental aspects of this type of development is you cannot puncture or penetrate the protective cap that seals the site or damage the nature of the slope surfaces, which are engineered to control groundwater control and so forth. So it's a highly engineered site when they're closed, and it's of the utmost importance that its integrity be maintained. With our approach, which I'll get into in more detail, we actually can place solar safely on the slope surfaces. So the image of the right is an example of what we can do with our approach. You can see that by using the slopes, we're adding another 1.32 megawatts, which is about almost 23% more power producing capacity. So some sites we can add capacity. Other sites, we're the only option to develop them at all. This is a view of a site that was closed with almost like a pyramid shape. This is looking from the top down, but you can see it's all slopes. So without our approach, this site could not be developed. But with our approach, you go from 0 to 18 megawatts. So it's a huge capacity that we can generate. But it does vary by site, from site to site, because every landfill is so very, very different. Our solution is a two-part solution using a patented ballast system and a patented racking system. The racking system and ballast system together can be used on slopes up to 40%, which is 22 degrees or a 2.5 to 1 ratio. And that is unique to us in the industry. Traditional racking systems with the cement ballast approach really can't be used on anything more than a 10% slope. So we have a unique capability in the industry through our patented approach. The racking system has a number of benefits in the way the number of modules that we can support. There are 20 modules in a 4x5 grid, which means we have a high ground to cover ratio. And also the way they're assembled, we can set them up and assemble them much faster because we don't use nuts and bolts. We actually use clevis pins. So a very simple but effective alternative. The ballast system, also patented, does not use concrete. Instead, we use an eco-friendly slurry, often called a flowable fill, which is a common construction material. But we pump the flowable fill into drainage pipes, which we call our ballast tubes. And these are flexible, and they contour to the slope of the landfill, and also through the clamps that actually hold the pipes together. We make contact with the landfill surface without penetrating it. And we get about 8,000 pounds of downward pressure. And that pressure is not localized as it would be with a concrete block. It's actually spread out over the length of the ballast tubes. So we distribute the weight evenly.
Hi, Scott.
Now, yes?
Your 5 minutes is up, so you can answer or describe anything else in the Q&A portion.
I'd be happy to.
We'll take a moment for the advisors to begin submitting their questions, and then we will begin the Q&A. What is the potential size of the market for this?
It varies because you have to consider the state of the landfill. Currently, EPA tells me there's about 10,000 landfills in the United States. About 2,000 of them are active. So that means about 8,000 of them are closed. Every landfill has is closed differently. So again, some have mounds, some do not. It's very, very difficult. And one of the goals for the next round of our involvement in the Solar Prize is to work with NREL and the EPA and come up with some realistic numbers to better quantify the actual size of the opportunity that we represent.
Great. What is the additional cost for the system compared to standard ballasted system?
It is a specialized system. We don't propose using our system for the entire landfill. It's a specialty application, and all we want to do is the slopes because that's where we add significant value. The cost delta is about 20 to 25%.
What is the usable life of the slurry tubes before failure?
Both the racking system and the ballast tubes have been tested. We actually have a stamped engineering report that was done by TRC, a major international engineering firm, and they vetted our system independently and certified it as safe for use on landfills. And that was one of the aspects that they considered. A typical land lease would be 20 years. Certainly the aluminum construction of the racking system and the ballast tubes will outlive that. The ballast tubes are drainage pipes, so they're meant to be buried. They're meant to hold water. They're very durable.
Interesting product. What would this apply to other sites with environmental issues that makes penetrating the surface impossible or risky?
It does. And I want to add that we already have a minimal viable product. As you saw some of those photographs, we have sold this system for residential and commercial use. Our proof of concept is not about the product. It's about the application. We're rethinking this approach and focusing exclusively on landfills and other similar sites. And I'm happy to report that, we wouldn't have a proof of concept if we didn't have a landfill. And just as of yesterday, we're working on an agreement. We have a site located. We have the permission, a verbal agreement, and we're putting it in writing to actually install this on a Superfund site in New Hampshire. We have the go-ahead from the trustee. The EPA is on board, as is the New Hampshire Department of Environmental Services. So I'm very happy to report that what we've been working for the next phase of the solar prize is actually a true landfill deployment. We know we can install this, but it needs to go through the engineering and regulatory review so that it will be accepted by the industry.
Okay, great. Thank you very much, Scott. That is the end of your time.
Thank you very much. I appreciate the time.
We will be taking a 5-minute break. After that break, Leap Photovoltaics will be the first team up. That's David and Matthias. If you could get ready during the 5-minute break, we'll see everybody back at 2 p.m. Hello and welcome back. Leap Photovoltaics, if you are ready, please share your screen and we will begin your 5 minutes.
All right. How's that look?
Looks great.
All right. Well, let's get started. I'm David Byrne-Needleman. I'm the founder of Leap Photovoltaics. I'd like to tell you how we're revolutionizing solar manufacturing. So the solar supply chain threatens our climate goals. We've seen recent disruptions from the pandemic, from problems with international shipping, and from import seizures due to forced labor in China. And at the heart of these challenges are the silicon wafers that right now power 95% of the world's solar panels. And because the US can't compete on cost, we haven't produced wafers in this country since 2016. And in fact, manufacturing these wafers is so complicated that over 90% of the wafers that are available for purchase globally are produced by just 2 overseas companies. So at Leap Photovoltaics, we're developing a groundbreaking manufacturing process that eliminates wafers. We go directly from refined silicon to finished solar cells. And this approach links the pieces of the solar supply chain that already exist in the US in order to create entirely American-made solar. Our breakthrough combines recent advances in additive manufacturing, in coating technologies, and in the formation of electrical contacts in commercial silicon solar cells. And it enables us to retain the performance and the reliability of silicon cells while consuming 90% less silicon and 70% less energy than traditional wafer manufacturing. And this combination means that we can match the performance of imported cells while using local supply chains and with costs that are globally competitive. Existing alternatives to the wafer supply chain either try to make wafer manufacturing simpler, or they try to replace silicon with established thin film materials like cadmium telluride, or with new materials like perovskites. Now, Leap has lower cost and better performance than kerfless wafers, and those wafers actually still need to be integrated into solar cells by a handful of overseas companies. Meanwhile, traditional thin films like CadTel can't match the performance of silicon, and new thin film materials are notoriously unstable, and most of the commercialization plans for them actually involve pairing them with silicon wafers that are manufactured overseas. Customers we've spoken with will not accept lower performance, and they can't afford to pay more for cells. And that's why they're so excited about our breakthrough at Leap. They've outlined 4 key metrics to us to prove performance equal to wafers. And these are absorbing sunlight as well as wafers, and collecting the electrons that sunlight generates without losing too many of these electrons to defects in the silicon, to parasitic current pathways, or to resistive heating. In the set phase of the American Solar Prize, we demonstrated optical absorption equivalent to wafers. We validated that performance with measurements at Livermore National Lab. And we're now working on scaling up this process at the Washington Clean Energy testbeds. We also demonstrated equivalent material quality to wafers with bulk and surface electron lifetime measurements at UC San Diego. And this week, actually, we're moving into a new lab where our partners, Materials Research LLC, are using their decades of experience to help install some new equipment and to develop some coding processes that will be critical to even better performance and to device fabrication. We're also working with the second group at Livermore to test shunt resistance, and we're expecting results from those experiments next week. And we're starting collaborations with ASU and hopefully with NREL through the Solar Prize vouchers in order to validate contact resistance as well. These collaborations will also be crucial to developing high-performance prototype cells in the second half of this year. And then next year, we aim to scale up these prototypes to pilot production. We already have one signed LOI to test these cells with customers, and we're working on a second one that will bring us up to our first $1 million in sales. Demonstrating performance with these early customers will position us to bring solar cell manufacturing back to the US. We aim to build the first ever gigawatt scale silicon solar manufacturing operation in America by 2025 in order to truly leap into a new era of US solar manufacturing. Our initial goal is to sell to US module manufacturers. These companies already purchase about $500 million of solar cells every year. And we want to work with them to build their market share here in the US and also to help them expand to overseas markets, which are projected to be over $40 billion per year by 2030. Leap's technology can also enable new products and broader electrification of the economy. And this expansion would mean deeper decarbonization and a market for us that's twice as large. We have a great team. We've got engineering and business experience working with startups and established solar manufacturers and equipment suppliers to bring new technology to market. And we're committed to making the best solar cells in the world here in the US. Our CFO, Matias Machado, is also on the call today, has executed dozens of financings for high growth technology companies. And he previously spent years on the engineering side developing large scale infrastructure projects, including concentrating solar plants. We have advisors with decades of experience in solar R&D and entrepreneurship, and we're growing. We actually have an offer out this week for our first in-house engineering hire that we're very excited about. And we'd also like to invite you guys to join us in taking a leap forward in clean energy.
Thank you very much. We will now begin the Q&A. Can you define the customer you spoke with? Is it a panel manufacturer, DG construction managers, utility scale construction managers?
Panel manufacturers. So we're targeting US panel manufacturers who right now are importing cells and then assembling panels in the US as our beachhead market.
Great. Is there any other impacts to the panel? Strength of the panel, hail resistancy, dimensions, etc.?
Yeah, so we actually see advantages in a lot of those categories. Wafers are extremely brittle and relatively fragile, and you get a lot of microcracking, which leads to either performance loss or total module failure. We don't have those issues, so there are potentially a lot of improvements in the durability of the panel. Wafers are also a very specific size because it's how big you can grow a silicon ingot. We're not constrained by that. We can sort of cut to size as desired by customers. Yeah, there are a number of additional benefits that we're hoping to realize down the road and also subsequent generations of products.
Great. How do you plan to use the funds from the program if you move forward?
Yeah, great question. So I think one, we want to continue to grow our team. And two, we're really excited about the voucher program. We have some groups that we've been speaking with at NREL to work on some of these contact resistance issues. Forming metallization for our device structure is a little bit tricky, and it's a problem that we're excited to tackle over the next few months.
What is your cost comparison versus current solutions?
So, you know, it's hard to say. We're hoping by the time we get to pilot manufacturing, we'll have a really rock solid cost model because we'll know exactly what our process is going to look like. We'll have gotten quotes for all of the tools for this pilot line. That'll be the same in high volume manufacturing. But right now we estimate that will be about half the cost of imported cells. And, you know, there's some potential there, but we really don't see going anything less than 25% of the cost.
What is the energy consumption differential of your process compared to the current process, i.e. cost of energy?
Yeah, so that's actually a big area where we have some advantages. So producing ingots in particular is extremely energy intensive, and then you end up throwing most of that silicon away. So we think we can save about 70% of the energy that goes into manufacturing a solar cell.
From a high level, this sounds great, almost too great to be true. My concern is making sure you are getting voice of customer and acceptance from the EPC world to make sure there's a market for the finished good panel.
Yeah, so all the customers we've spoken with have been very bullish on both product certification. So certification for panels happens at the module level. It doesn't happen at the cell level. So they're the ones who are going to have to deal with certification. And so far, nobody has expressed any concern about that. You know, we're using established materials and off-the-shelf equipment. And so one of the nice advantages here is that traditional cell and module testing translates directly to our products. So people are telling us, hey, if you can pass standard certification testing, we're excited, we're happy to warrant it, we're happy to go certify our product.
Great, and that's the end of your Q&A time. The next
All right, thanks,
team,
everybody.
thank you. The next team is Gizmo Power. When you're ready, please share your screen and we can begin your 5 minutes.
Let's make sure my sound is okay. Everybody can hear me?
Yep, we can hear you.
Very good.
Just want to let you know that we are recording the entire event, so you will get that YouTube link eventually, Gizmo Power.
Very good. You haven't started that chat, that stopwatch yet, I hope.
No, no.
Thank you.
When you get to presentation mode, you will.
Awesome. Thank you. Good afternoon, everybody. I'm starting. Americans have so many excuses for not going solar. Electricity bills are skyrocketing, but for moderate income Americans, a rooftop solar system is unaffordable. And what if you want or have to move? Many have complications with upgrading their roof. Most properties are too small for a ground-mounted system, and those that are large enough are often constrained by setbacks and other regulations for permanent structures. Don't forget the contractor and permitting red tape, not to mention hurricanes and tornadoes, which can destroy permanently installed systems. Until now, there's no powerful or practical solution for renters or owners who want to be able to move and take a system with them. Introducing Gizmo Powers, Mobile Electricity Generating Appliance, or MEGA, America's first portable carport that taps into the renewable energy potential of an underused urban surface area, residential driveways. This common sense solar deployment method drastically reduces soft costs associated with custom engineering, design, and permitting of permanent systems. The MEGA integrates commercialized components such as an EV charger, inverters, optimizers, and bifacial solar panels into a system that shades and charges your EV and home and wheels right in and out of your garage. As a portable appliance, the MEGA carport is easier to maintain, repair, upgrade, and protect than a conventional rooftop solar system at a fraction of the cost. In February 2021, we connected the first system to the electric grid and to the online monitoring platform, allowing us to quantify the electric power production. The annual data shows that a dual rack MEGA can cover the electricity consumption of the average single-family home in the southern United States, and at 2/3 of the cost of rooftop solar. That's throwing in the shading and charging of the EV as the cherry on top. Since we won Ready, we have upgraded that panel wattage, improving visual appearance and ease of assembly and shipping per user feedback. The Florida Solar Energy Center issued certification for the portable MEGA's plug-in electric grid connection by means of a simple 240-volt outlet. Gizmo Power is participating in the VentureWell E-Team grant, the Cornell-based Rev Ithaca Hardware Accelerator Program, and Capgemini's Positive Planet cohort. We have also applied for a Department of Energy SBIR grant to explore the use of backup batteries in combination with the MEGA. The utility patent was submitted in April of 2021, as was our trademarked concept of solar on wheels. Commercialized solar solutions exist that are just as powerful, but not portable. Then there are products that are portable, but not as powerful. Solutions which are both portable and powerful are prohibitively expensive or require dedicated single-use real estate. being the only portable grid-tied distributed PV system on the market with a competitive price point per installed kilowatt. Gizmo Power projects reaching 1% of the PV market within the next 10 years, and we can imagine the scale of opportunity being even more. Kirk Moust, the CEO of Solar Direct, has committed to delivering the Mega to Floridian customers. He sees that Megas are faster to assemble and maintain, resulting in several deliveries in one day, far more effective than installing custom rooftop systems. Funds from the SET contest phase will allow us to team up with the 2020 Solar Go Prize Go winner, Max Out Renewables, with their Evergrid, bringing a portable, affordable solution to market that operates off-grid during power outages and under natural disaster conditions. For the SET stage of this competition, we secured a cooperation with Sandia Labs and Intertech for UL testing and certification. Freedom Systems Center at North Carolina State University will sponsor our demo day for functionality and testing. We also have an agreement in place with Mercury Corporation in Ithaca, New York, to improve the mechanical design for mass manufacturing. Once UL certification is in place, Gizmo Power plans on scaling up manufacturing and selling Megas directly to solar installers. We will also look to license the technology to third parties. The Gizmo Power team has what it takes to deliver Megas into the driveways of moderate income homeowners and renters who want to power both their EV and home with renewable clean energy. We thank Carnegie Mellon and the judges and look forward to your questions.
Was exactly 5 minutes. Great job. We will wait a moment for the question and answers to come in, and then we will begin the question and answer period.
I see the president is online and co-inventor.
Hello, Antonia.
Hey.
Okay.
Thank you so much for having us.
Your first question is, homeowners associations or HOAs typically establish rules for a neighborhood's aesthetic and sometimes attempt to restrict homeowners' ability to install solar. How do you plan to overcome HOA related issues?
Would you like me to answer that, or Tony?
I can give it a shot and then you can follow up with it.
Yeah.
Right now, it's sort of, we're seeing it as a way of, there always has to be a point of which it's a breaking point for changing the norm, changing the status quo. Gizmo Power is definitely something that changes the status quo. So the idea is if we are able to get one HOA, any HOA, to be on board with us and see what an amazing, incredible opportunity this is and sort of ride that wave, we're hoping other HOAs down the line will see how this is actually a very beautiful and aesthetically pleasing thing to have in a driveway, and it's also simultaneously protecting the owner's cars. And so we're hoping down the line it's going to sort of make it through popularity, will make, because it's just a matter of aesthetics, because a lot of people, HOA is saying, oh, you can't have a basketball hoop in the driveway. So there's, as you know, there's those logistics. That would be my response to that.
Yeah, but also there is really a legal boundary. In Florida, there is a law against homeowners associations forbidding the renewable energy generation systems. And since the system is on wheels, there is really also the question, I don't think they have any jurisdiction to say this is not really allowed because it's not a fixed structure. Our goal is really, and what we are aiming for is to have an appliance which is not a fixed structure and thus does not apply to setback regulations and those obstacles.
Great. Can you speak to how you have addressed wind loads for the structure?
Wind loads are, the system is really going to be tested for UL 2703. That is really the same UL standard that really applies to rooftop and ground mounted systems. And we're aiming to meet Miami-Dade hurricane codes. If the system is permitted as a ground mounted structure, you can alternatively put anchors into the ground and really anchor it, but then it's a fixed structure. We are aiming for the normal application of this system to be wheeled into the garage during a hurricane outage. So we want to really cover both cases, basically.
What is the full installed cost?
Well, we hope to be able to do it for under 20,000. So it's going to be 18 to 19,000. Prices go up a little bit right now.
Great. And that's the last question for your Q&A. Thank you very much. The next team is Sundeck Solar. Seamus, if you want to share your screen, we will begin your 5 minutes.
Can you guys hear me? Can you see my screen?
Yep.
All right, great. So thank you all the panelists, judges, and thank you for all the other companies and ideas. It's really great to see such innovation out here. So I'm Seamus Kale with Sundeck Solar, really power for your daily commute, and it's a standard modular EV charging frame that's kind of human scale, designed to fit into any parking space. So let me go full screen. So basically, one of the things that we built this on is if all cars will eventually be electric vehicles, then we believe all parking spaces will eventually be solar charging stations. But in order to reach this future state, we need to help accelerate this with different alternative ways of providing this through modular solar charging stations that greatly reduce the installation time and cost of current available options. So we look in the market, basically, the market will increase by 14 times in the next 10 years with the introduction of more and more EV on the road. The EV charging stations are trailing basically the introduction of more EVs on the road. And if we look at solar in particular, the current charging station options are too high, basically as much as 10 times more than a current level 2 charging option that many people just put into their residence or office park. We also believe that one way to solve this is to focus on charging at work or really wherever your car is parked during the day. So this basically maximizes the ability to take advantage of the charging time of day to align with the highest output and also minimize storage or battery costs through that method. So if there's so much opportunity for EV charging stations, I guess the question we should ask is, so how can we see so few solar powered EV charging stations? And the primary reason for this is the current EV charging stations have high costs for really two areas. So one is over half the cost of solar powered EV charging stations is due to non-hardware costs, so design and installation. So we see these are highly custom, basically detailed for each individual site, et cetera, which really inflates the cost of these installations. There's also hardware costs, but hardware costs are there, but we're not really seeing that as a primary driver. So really, it's the intent of our product is to reduce the non-hardware costs through simplified installation and a much more simplified design. We also do believe that we can scale down the design of hardware costs, which we'll get into as we go forward. So really, where do people charge their EV and kind of what do we see that happen today? We could see charging at home, where we're basically taking advantage of that. As many places actually have an apartment or a rental, you can't install some things, as our previous contestants just mentioned, or you can charge on the go, where you might need to charge very quickly using kind of more rapid chargers. We believe that charging at work, or effectively where your car is during the day, is the most optimal position for solar EV charging. So that could be commercial office parks, industrial parks, auto dealer lots where basically cars are in inventory, and also apartments and different public sector things like schools, universities, and public buildings. So we do believe that that's the most optimal area, and that's why our solution is designed really around the work environment. So what do we see at those work environments today? So typically we see level 2 grid-tied chargers, which can cost anywhere from $2 to 14 grand, with an average about $6,000 install cost. We also have standalone EV charging stations, which are highly expensive today, ranging from 30 grand for basically a custom structure to $70,000 for a drop ship, fully assembled item, or we see a EV charging pavilion. So with these costs, we really see that businesses the level 2 system becomes the most common. But the issue with that is basically that cost just takes into account the initial installation costs. We have a lot of vehicles that are now starting to basically fully charge their vehicles at work for free. And basically, if you look at $600 a year in charging per vehicle, if you have 5 different vehicles using that space to do full charges, that workplace could be looking at $2,000 to $3,000 of energy costs. So that's basically really increasing the cost for that. So when we talk to customers in the customer discovery, we basically said, are you interested in solar EV charging options? And most of those companies came back and said, well, we are, but there's a significant cost issue. If you can come up with an option that basically allows us to do L2 grid charging costs with solar, we'd be highly interested. So introduce SolNext Solar, which is powered for your daily commute with a simplified install, can be off-grid or grid tied, and we do believe has the lowest cost of ownership. So how do we get to the lowest cost? It's really, we focus on power for commute. This is a micro-sized charging station that is designed to charge your vehicle for the duration of your daily commute. So we have 3, 4, and 6 panel offerings that basically do pass-through charging and basically can recharge your vehicle for the average commute times in the US. We also, this simplifies the structure of the charging frame. It lowers the cost of the solar panels and basically also reduces the battery requirements as well. We can grid tie these, which allows us to basically have the advantages of grid, but lowers the operational cost over the long term for businesses that do install this as a charging option. We have a simplified install process that basically.
Hi, Seamus.
Yes. Oh, yeah.
We're at the 5 minutes, so
Perfect.
any of your questions we can cover in the Q&A. So we'll wait a moment to receive the Q&A questions. Do you have any IP around this technology?
We have engaged Tuggle Duggins law firm to do initial patent search on the self-raising aspect of the charging frame. So, but we're at the beginning stages of that.
What are the low-hanging fruit use cases for early sales?
So we have market development in a couple key areas. So one would be commercial real estate. So we have a leasing firm that's helping us with market development to basically add on these via green leases. So if you look at a leasing agreement, you can basically include that in a new lease agreement for a building and roll in several charging stations. There's also an interesting one. We have the founder of Contact at Once, which basically sold into the automotive dealer network across the country. And so those basically, if you have dealer lots with more and more EVs, they need low cost EV charging stations where the car may be parked there for multiple days. So if you do passive solar charging through our lower cost options, then that's something that's there. We also are working with an apartment operator in North Carolina that basically operates lots of apartments and is looking for lower cost solar options. So they can basically reference, solar charging options to replace the current L2 kind of grid tied charging stations.
Do you have concern with level 2 becoming faster and faster charging and 4 miles per hour being obsolete?
So not really, because I think you keep going back to if it's charging, if it's faster and faster charging, that's not the use case we're after. We're after a car that's parked, for a work day, right? And so if you're looking at, what's the need of that business owner, operator, or commercial real estate operator, they want to offer spots at the lowest cost. So they came back, the customer discovery told us over and over again, they, can do some level 2 charging. The current anticipation alliance places that is free to the tenant. Maybe a cost rolled in. If you look at the ongoing energy costs of trying to provide that, you can basically do this for maybe 50% more cost. Our cost is going to be around $8,000 to $10,000 per spot, where an L2 charger is industry average is around 6,000, ranging between 2 and 14. And then, so really kind of look at this option is it's similar cost, but over the lifespan of that, basically having that the charging station in place, ours provides a lower total cost of ownership to that real estate operator, be it a commercial or a auto dealer or a apartment operator.
One last question. What is the size of the solution? Will it ultimately decrease the amount of available parking spaces in a lot?
No, this fits into a single space. It's effectively a pole mount system has a small form factor of 3, 4, 6 cells. So it's uniquely designed. It can fit next to it. Can be a parking space next to a structure. It can be set up in between the parking spots like that. So it's specifically designed to have a small form factor and not take up. It doesn't. You don't eliminate parking spaces through the install. You don't lose spots when you install this.
Great, and that's the end of the Q&A. Thank you very much, Seamus. We will now have Mana Monitoring share their screen and video.
Hi, everybody. Hello. All right, let me go ahead and share my screen here. And can you confirm you can see our slide?
Yep.
Okay, great. Well, thank you for joining me. I'm here representing and CEO and president of Mana Monitoring, and the technology I'm introducing today is Meter, Mana-enabled distributed energy resources. This is a brief overview of our team, a team of environmental economists and software and hardware engineers. Brief background of our company. We've been operating in the commercial industrial solar space for over half a decade. We monitor about 500 megawatts of solar nationally. And we're strong regionally in Hawaii, but we also have clients nationally as well as in the Caribbean. And the problem we're looking to address with Meter is basically a combination of solar, electric vehicle charging, building load, and battery energy storage system. And the issues we're seeing coming up on the solar industry is that net energy metering is coming to an end. We see that playing out across the nation, which results in smaller solar PV sizes. We're seeing level 2 electric vehicle charging stations being built out across the country at commercial facilities without a dedicated smart meter or load control. And we're seeing peak demand charges spike across our users. And we're seeing all of these DERs operating in silos and not being harmonized. Our solution to this is centralized management with what we call Meter, which is a plug and play device that enables larger PV systems. So instead of curtailing them, we're using the solar power to charge electric vehicles at commercial systems so that the cars are truly running off solar energy. And we're also working to eliminate peak demand charges by coincidence peak demand that level 2 electric vehicle chargers result in. So the markets that we're operating in are primarily the solar, battery, and EV markets, which all share the similarity that they're at the beginning of the hockey stick. So massively growing markets. And our technology, I'll speak a few words on that, which is called Meter. Basically, it's a meter coupled data logger dash site controller, and it runs our proprietary software and basically synchronizes and coordinates solar with electric vehicle charging. So it's basically an integrated data logger and site controller with integrated machine learning algorithms to be able to better predict facility usage and to synchronize that with electric vehicle charging habits. Basically, we're bridging the gap between the host facility and electric vehicle chargers. So EVSCs or electric vehicle charging equipment vendors basically are focused on the user experience and the monetization of electric vehicle charging. We're here to represent the facility and to help them cover their costs and help mitigate the hidden charges associated with electric vehicle charging, namely demand charges. So our revenue model is very straightforward. There's a hardware fee involved when installing the meter, and then there's a software as a service fee, which is basically providing that we eliminate peak demand charges. Our market is basically EPCs, solar installers, and commercial facilities. It's very straightforward in how it works. So when you're installing electric vehicle chargers, there's a pretty large capital cost involved. And if you couple that with a meter, we can eliminate demand charges and leverage your on-site solar PV system. So it's basically 5% of the CapEx. So it's somewhat of a negligible cost with an ROI of less than 4 months. And once the system is installed, it basically starts taking that time series data of your facility usage and builds a machine learning algorithm off that to better predict in the future when you have your peak demand charges approaching. It'll deactivate charging or reduce the amperage flowing through there, and also predicts the amount of solar based on the weather model, and synchronizes that so that electric vehicle charging is activated when solar is at its peak or when it's going to exceed the facility load. So thereby you don't need to curtail your system, you charge your electric vehicles there. In the ready set of the American-made Solar Prize Challenge, we built our concept and data logger. In the past 4 months, we've deployed about 8 of these meters across 2 commercial facilities, and we've started to integrate about a 0.5 megawatt of Tesla battery energy storage systems to be able to synchronize those as well. In the go phase of this, we will be testing our product and also integrating with NREL some of the security challenges needed to be able to maintain the secure grid at the grid edge, which is becoming increasingly important as we see a lot of cyber threats out there. And we want to make sure this is part of a smart, intelligent, and safe grid because that's where we operate, is at the grid edge. So right now we have meter deployed with the Hawaii Department of Education, where we are monitoring 4 EV chargers, 200 kilowatts of solar, and almost a 0.5 megawatt of batteries. And we're doing exactly that. We're reducing their demand charges and ensuring that the solar isn't curtailed, rather it's used for EV charging. So instead of going in the morning and plugging in your EV and it starts charging automatically, we restrict that charging to be able to synchronize it with when the solar is at its peak and when the utility rates are the lowest. We're also running a pilot project with Jones Lang LaSalle, which is one of the largest real estate management companies in America. And we're using this at one of their properties also to leverage their on-site solar and to reduce their peak demand charges. That's basically it. Thank you.
Thank you so much. We'll wait for the first question to come in and then we will start the Q&A.
Sure.
Advisors, whenever you're ready, please submit your questions in the Q&A feature. Oh, the first question. How do you plan to use the funds from the program?
Sure. We have 2 things we need to do. One is ensure cybersecurity and make sure that we're communicating over secure channels so that we can fit into the distributed grid architecture. So with NREL, we're working with their cybersecurity team. That's one big part of it. The other one is to work with equipment vendors. So we're in discussion right now with 2 EV SE manufacturers as well as 2 smart meter manufacturers.
Who are your competitors?
Competitors can kind of fall into 2 categories. On one end, we'd have competitors that are standard like building management systems, such as like Siemens and Schneider, but they kind of fall short when it comes to EV charging. And on the other hand, we do have EV charging companies, but they're not really into building management or peak load management. So kind of on the 2 spectrums we fall in between.
Jennifer is unclear on the problem being solved. Is it to reduce demand charges? And if so, how does this compare to storage plus battery, initial cost, and added benefit?
Sure. So primarily our focus is to ensure that the solar energy being generated is used on site rather than being curtailed. So as we see that metering being reduced across the country, we want to make sure that we can still maintain a relatively large PV solar system size rather than having to dial that down to the exact load at the facility. And when it comes to demand charge reduction, our focus is to be able to synchronize the facility load with the actual demand so that we can predict when we're approaching peak usage and thereby reducing the amount of charge flowing to the cars.
Is there any place besides Hawaii that is curtailing C&I solar these days?
Sure, we're seeing the battle play out right now with the California PUC. We're also seeing that happen in Georgia and Florida as well. So it's a very common trend. So Hawaii has the largest or the most solar per capita in America. So a lot of the things that we see happening on the utility level in Hawaii is actually kind of foretelling what's going to happen in other utility territories. as well as EV adoption. Hawaii has one of the largest EV adoptions in the country. So that's kind of coming down the pipes, and developers and commercial properties are faced with the question of, do we then dial back the size of the solar PV system, or do we have to couple it with batteries? And in a lot of instances, coupling with batteries is prohibitively expensive. So this is a much cheaper solution to be able to build a larger PV system and leverage the power on site versus having to either curtail it or design and build a smaller system.
Is the focus on markets without net metering or penalties for grid export?
The focus is basically on all markets. So demand charges are going to be present in any commercial scenario. And when it comes to solar specifically, we're looking at even if you do have net metering, you still want to try to leverage as much solar on site as possible. But of course, the value proposition is much more powerful when you don't have the option to export to the grid.
Thank you very much. That's the end of the Q&A period. And that is our last team. We want to thank all of the session 2 teams. All 8 teams did an excellent job. We are going to be taking a short break, and we are going to return for the advisory panel at 3 p.m. Please stay on this Zoom link to be able to listen to the advisory panel. And after the panel at 3:30, please switch over to Remo, where we will be having our networking event with competitors, investors, industry professionals, and experts. We are very, very thankful for all of the participants in today's showcase, and we're very excited for the advisory panel discussion at 3 p.m. All teams can expect to receive additional feedback that we collected today at some point early next week by email. Thank you very much, and we will see you at 3 p.m.
Okay, everyone, it's wonderful to see you again this afternoon. We are going to get started with our advisory panel. We have a couple of panelists who are we're still waiting for to get back on, but I wanted to make sure that we get started on time because it's a short amount of time before our networking session. And so really important to hear the insights from this group. So what we're going to do is we're going to have all of you, after I walk through I'm just going to give your titles, because again, we just have a very short amount of time this afternoon. I want to use it for your insights, not your interest. So on our panel this afternoon, we have Josh Beck from BCI Technology Investments. We have Jeffrey McDaniel from Innovation Works. We have Sakshi Mishra from Microsoft, who is a CMU alum. And we also have Phoebe Wang from Shell Ventures. Now I know that we also have Judy Lee, who's with Energy Foundry, but she has not yet joined us. She's going to be in here in just a few minutes. So with that, let's turn on the cameras. Let's take the slide down and we have everyone. Yes, and so we're still just waiting for, oh, Judy, you're here. Good, fantastic. Everyone is with us. So we're going to spotlight this group. And I am really excited to not only see all of your faces, but also ask you the hard questions because you all have been a part of this exciting Energy Week, CMU Energy Week 2022. I'm hoping that 2023, we will all be standing next to each other, shaking hands and high-fiving. But for the interim, we are doing the best that we can. So we've got a great group here with us. And what I want to do is start with sort of an overarching question. And again, we have 30 minutes, so concise is going to be really important. So each of you was a judge during at least one activity this week. So I want first, please, your name, a quick bit about you, really short, and then tell us which particular event you were a part of as I ask you this first question. So remember all that you're going to have to give me in this first question. Tell me a little bit about the most impactful thing that you heard about this week. And it's not just an innovation. Maybe it is a specific innovation. Maybe it's a particular trend. And since this is a really, really hard question, I'm going to start with Judy Lee because Judy has all the answers. So Judy, we're going to go with you. And Josh, you're going to be up next.
All right. Well, hello, everybody. Oops.
So Judy,
my video still working?
It is not, but just keep talking because we can hear you until it comes back on.
Let me see. Okay.
Perfect.
Okay, there we go. Well, hi, everybody. It's great to be here. Thank you for inviting me to be part of I was on I was on this session, the second session on Tuesday for the American Made Solar Prize.
So for software,
The
good.
software,
Okay.
right. And an impactful thing that I've been thinking of since that session was there are a lot of new ways or a lot of different approaches to how do we use the data flows that are available to us. I heard a lot of conversation around using weather data and how that can be used in order to predict solar energy generation and other renewable energy generation, what that means, and catastrophic event forecasting. And so there is a lot of people thinking about the best way to make smarter decisions given the data streams that we're getting. They're more and more robust. Computing is more and more robust. We can build better and better models. And so to me, a big question that I leave all of you guys with is like, yes, the data is there, the technology, we can work the models, but also how do we productize this? Like, what's the best path to market to get customers to really hit their pain point on how they should be thinking about catastrophic events, why they should care, and how they're going to integrate this information into their businesses and why it's valuable. And so, I don't know, something top of mind for me, but I jumped right to it. But my name is Judy, and I work at Energy Foundry, which is a venture capital fund that invests in early stage clean tech, climate tech, sustainability, energy, whatever you want to call it, startups that are impactful. Usually we're at the seed stage. So really going in early and supporting these companies in their commercialization path.
Fantastic. Thank you, Judy. Josh, you're going to go next, and Phoebe, you'll be right after.
Yeah, great. And thank you, Judy. I think that was spot on. I'm Josh Beck, Managing Director and Chief Investment Officer at BCI Technology Investments. We're an A and B round clean tech investor, primarily focused on utility and commercial industrial scale solar. I think that's something, and I'm sorry, I participated in the American Made Solar Prize round 2 set challenge here. I think that the most impactful thing that I've been really thinking about is this massive trend of onshoring on the manufacturing side, all the way down to into the ground and into the raw material supply chain. So we're seeing a massive transition back into the United States. I think that, the looming Build Back Better and a lot of things happening with the infrastructure bill and all these things have provided a number of incentives. And it's really exciting to see how many of our entrepreneurs and their associated supply chains are bringing tentacles back into North America. Now, by no means are people avoiding East Asia or India or Turkey or all these other places in the world that are high manufacturing capacity locations. But we are seeing a lot of tentacles being brought back here to the United States to consolidate supply chains and mitigate supply chain risk. And that's creating a variety of options for earlier and earlier stage entrepreneurs, because now they've got more direct access to prototyping resources and to manufacturing and growth capital, because it's more aligning strategically with these larger kind of manufacturing operations.
Very insightful. Thank you, Phoebe. And then how about we'll do Sakshi next. Jeff, you'll be at the tail end, so make it good.
Sounds good. Thanks, Anna. And great to see you again, Josh. We did that like a solar prize last year, so it's good to be back. And I'm honored to be on this panel with the fabulous and intelligent panelists. So my name is Phoebe Wine. I'm the head of the deep tech investments for Shell Ventures, and actually covering the early stage investments as well. So yeah, and just a really quick plug for Shell. Shell Ventures has been around for 30 years. We're their venture capital arm for the role that Shell or Shell company these days. And we have like a $2 billion AUM with 1.4 billion new capital coming in to invest in companies. So definitely looking forward to some really interesting opportunities coming out of this prize competition. Things that I found super inspiring during my software session, I think I shared the same session with you, Judy, is that hardware is the new software. And I definitely see a lot of really interesting companies coming out, kind of combining both the software and hardware. And it's just a common and probably a very a trend has been around for a few years now, that you can't really go without software by doing your hardware, right? So we have digital twins for our power plants. We have like quantum computing to figure out what's the best kind of design for some of the hardware applications. So yeah, I think that actually I saw that in the software session, and it's just amazing to see so many competent entrepreneurs and being bringing their ideas. So super good. And yeah, I'll hand over to Sakshi and Anna.
Thank you. Thanks, Anna, for having me here. I'm Sakshi Mishra. I'm senior AI engineer with Microsoft. My background has been, I have worked at NRO before. I'm CMU alum and have been involved in energy industry from both software and hardware aspects. Have worked in transmission and, okay, keeping it super brief. So I have attended 2 sessions, actually, Energy Tech Up as well as American Made Solar Prize. So I'll focus on the Energy Tech Up feedback, because that's something I think we have not covered yet. So the event was yesterday, CMU has hosted it, and a couple of major trends I saw there. One was like the early opportunity for entrepreneurs with engineering background coming together to come up with a business plan for commercialization. I think it's in general, having that kind of opportunity at this stage where they are thinking more or less engineering technology phases, and the technology is pretty sound, giving them this platform to pitch their business plans and think through those. I think that is very important, because that's where I see more need of kind of concretizing their business models and being able to concretely put a number or quantification on what kinds of funds are needed, how aggressive can they go given the market conditions. So I think that's the next step for these startup ideas. And because I see the technology is pretty strong, productization and essentially quantification is something, if they add on top of it, it will accelerate their paths to really be able to get the technology to deploy on scale. Thanks.
Thanks for putting the pressure on me, Anna. I'm Jeff McDaniel. I'm a portfolio executive at Innovation Works, which is one of the most active early stage seed investors. We also happen to be located in southwestern Pennsylvania, so I'm here in Pittsburgh. I sat in on a number of sessions. I think I was doing software for the Solar Prize on Tuesday, but kind of a global observation is literally how global the concepts are. I was struck by a number of the applications and how they could be ported across borders in a way that I don't think we would have seen even a few years ago. So these are solutions that can be applied fairly flexibly, across different countries, several languages, and done so fairly quickly. I spend most of my time at Innovation Works working with hardware companies and software companies, many of whom are in the energy sector. And 10 years ago, we would not have had the regulatory landscape that we have today, as far as at least beginning to break down some of the barriers that have existed for decades with many of the ideas here. So I think there's as far as a trend is concerned, I think we are starting to see a convergence, kind of government interest in being able to support some of the emerging new technologies that we heard about this week.
So again, I know we have limited time, so I'm going to keep asking hard questions. But the big question for me is, what's missing? Like, what did we not cover? What gaps did you see? And I'm just going to throw it out to any of you, because some of you might say there were no gaps. We covered everything. But I really want to think about this from the lens of the students in our audience, because they're thinking about what their career looks like. So you could blend this nicely with a conversation about trends, like things that are going to be important in the future. But what was missing, if you saw anything? Or you can just jump right into the trend that you think is going to be most important. Who'd like to go first?
Maybe I'll go first this time, because it's a kind of a really good question. I'm pretty sure that I did not see the everything, given that I only attended one session. But one thing that I just from the angle of potential like a future career thinking, right? Solar is one of the renewable power that is super important, and we have a lot of innovations around that. What I have seen in the market is for us to be able to use the renewable power meaningfully, kind of being able to compete with the fossil fuel, being able to compete with nuclear, it is the intimacy of the power. So we do need to see the right storage facilities in addition to like the innovation around solar. So if you're thinking about your next kind of innovation in the renewable power space, and then or if you're thinking about the career, right, I think being able to make huge leapfrog forward on the energy storage, being able to do that and it can kind of store the renewable power in a meaningful way is going to be super important. Yeah, I just want to flag that is one of the key topics that I've been very interested in, and happy to chat more about that later. Yeah.
Later at the networking. So just you can unmute yourself if you want to go next is probably the best way to do it. But who would like to jump in with either a trend, an insight about something that students can be thinking about, or maybe something that was missing?
Yeah, I'll jump in next. I would say that covered a lot of basis. I would say going a little bit deeper on the transition from gray to blue to green hydrogen, I think is of the utmost importance for not only the decarbonization of the planet, but also for the future of science, and particularly applicable to the students listening here. I think that those who are going to CMU are sitting on a gold mine, or I should say a gas mine of opportunity of the transition, because I'm a firm believer that we're going to see a blue hydrogen transition into green hydrogen. In Western Pennsylvania, Eastern Ohio, the Panhandle of West Virginia is going to be a major kind of tip of the spear in leading that initiative as we decarbonize the planet. And I think that that's going to open up a tremendous amount of new technology branches that we're only beginning to identify in terms of how we can kind of further create an ever increasing efficiency within hydrogen production.
I can go next. So I want to share a perspective on the software side of things. So as we think about these new technologies, what happens is we have to integrate them with the grid, and integrating them with the grid needs to deal with the digital layer as well. And one thing I've seen in general is kind of this talent divide, where few folks know software engineering so well and few folks are very good with solar technology or wind technology itself. So there is a need for folks to have kind of combined skill set, and it does not necessarily have to be like very deep software engineering knowledge, but knowing a little bit of how to integrate these technologies on the digital layer of the energy grid is something I think it's kind of the skill set we need to build more and more as we move towards trying to build this grid of the future, which is bringing all these technologies together, be it storage or electric mobility or solar or new kinds of energy resources. So that's where I try and communicate it, like I'm trying to make sure I communicate it right. I'm not saying everybody has to know coding and very good software engineering, and they also have to, all sorts of energy technology details, but having the overall understanding of how they interact with each other, I think can be useful for students to carve out their career for the types of skills or talents we need as this whole transition is happening to smart grid. So, yeah.
I can go next. So sorry, Jeff, I guess that does leave you to be last again. So maybe what I'll just say is I really want to highlight the fact that whenever at least an investor like us and most others look at technologies and new ways of doing things, it's really important to us to be able to compare cost and to make the case on a unit economics basis that the cost of, let's say, hydrogen or the renewable energy that's being generated is competitive. And so I see a lot of technologies where it's very innovative, the new method of doing something, new technology is being commercialized, but it's still fuzzy. Like, what does this, like, at least estimate for us? Like, what could this be, like, as far as cost, and how does that compare with what's already on the market? And so I think, you know, that this goes for any new technology that's trying to commercialize, being able to clearly articulate why your solution is going to be cheaper than what's already out there, or if it's not cheaper, like, what does it solve that, you know, everybody really needs that current solutions can't have? And so that's just generally, I really like to emphasize that. And then with green hydrogen, I think this is something that I just keep wondering about, which is so many things that I see are about breaking up water molecules to create hydrogen. And that might work in a lot of places where there's a lot of water, but, you know, I would love to see some more technologies that take us in a cost-effective approach. It's cheaper to do green hydrogen in a way that isn't about breaking up water, because as we know, that can also be a scarce resource.
What every one of my distinguished panelists have already said, I totally agree with. I don't think I have anything else to add. So Anna, I'll let you go for the next question and I will try to answer it first.
I'm going to let you go first. So one thing I didn't suggest is we do probably have time for one question from the audience. So please use the Q&A. Give me a really good doozy question that I can ask the panelists, but if you send it through the Q&A, type quickly. So Judy mentioned the idea of how she really wants to make sure that when a young company comes to her and is asking for investment, that they focus on financials. So what are some other things that these folks, as potential, they're coming into your office, virtual or otherwise, and they're pitching an idea to you? What is something, but between all of us, we can sort of put this together. What's something that maybe they don't think of that you are really thinking about? Maybe it's something that you're always looking for. I don't know, it's the je ne sais quoi, the special sauce. Give me a little bit of insight into what they should be thinking about. See, Jeff, now I give you a really hard one and you're the first. You may not have time to think about it.
Yeah, when I said I wanted to go first, I meant the next question after this one. You know, I mean, there are a number of things that I think the investors on this panel are looking for. And Judy brought up a good one. And I want to hit that one just for a moment, and then I'll try to answer with another answer there. Is that many cases, the companies that we see that are in this space, while they've done a little bit of customer discovery, they have a little bit of a disadvantage against maybe some of their non-energy technology related startups that I spend a lot of time seeing also, because and I've said this, I think, every year of Energy Week. The folks that participate in Energy Week have a particularly high energy IQ. When you leave the lab, when you leave the garage, wherever you are, and wherever you are doing your heavy thinking and you're starting to socialize that with other people.
That's right. We've drunk the tea. We've all drunk the tea.
You have to remember that not everybody has that level of energy IQ. So as you're communicating the economics of your opportunity, you often have to provide, briefly, a solid, crisp context of how is your solution fit into the existing world or the future world. So I would encourage all of you to think about how you can leave this space today and continue to educate those around you who may not know exactly where the energy comes from that powers the light bulb that just turned on, or the laptop that you might be looking at this event on today.
Very well said. And it's very true. Any other insights on this one, Phoebe?
Yeah, I'll go next. I actually have a list. If you're going to pitch for VCs, right, you have your normal like a market, TAM, team, etc. Specifically for hardware, I think that's kind of the topic for, and especially many of you are going to that route. I think things that you do want to get your prototype, you want to make sure that you're familiar with the TRL level and being able to talk about that intelligently. And then also like a lot of times you would be like asked about whether you have a pilot, whether you're a team member, have experience working with large corporations that can help you to pinpoint of who to collaborate and how to do that, like your very first pilot project with either companies or government. So those are the things that you do want to kind of think about it, especially you're in solar, you're in hardware or deep tech. In addition to kind of all other stuff that you need to worry about compared to normal companies or normal startups. Yeah, and hand over to Josh. I know that he always has a lot of wisdom there.
Thank you, Phoebe. That's great. And that kind of builds off of what I was thinking on the collaboration side. You know, what I always look for, and this is a core point in our due diligence, and what a lot of entrepreneurs will find with venture capitalists is, you know, I've got young kids, you know, I'm always looking for entrepreneurs who can play nice in the sandbox with others, right? So I'm looking for entrepreneurs who know how to collaborate. You know, if you are the most talented researcher or scientist in the world and you've surrounded yourself by the three, you know, number 2, 3, and 4, that's all great. All I hear is, sounds like you guys are living in an echo chamber, right? So then I'd like to see more entrepreneurs reach across the aisle to the commercialization and the business folks. I know that that can be really scary. I know that you might be scared about someone taking your IP. You have to be confident in your technology set, and you have to strive to make strategic partnerships that link the commercial and the technology side, because one without the other significantly increases your chance of failure. And when you link them together, it dramatically catapults your chances of success forward.
If we have time, I can add one more quick point there. Okay, so it's the ecosystem approach. So one thing I found is that if we are building or pitching a new technology, it can be something like we are always tempted to say that it's a disruptive technology going to disrupt everything and our product is great. Okay, there is innovation and that's great. But if we are able to show that the product we are building is actually work within the ecosystem of technologies of today or tomorrow, saying that if we are, let's say it's a new kind of solar panel with more efficiency, how does it work? Will it be compatible with the existing inverters? Will it be working with the standards which grid has set up? So as much as it is required for the product to be innovative and showing that this is how we are solving the customer's pain point, it is also important to emphasize or start thinking about how will once product is there in the market and it gets integrated into the ecosystem, how will it play well with the ecosystem? Because that kind of determines the adoption potential of the product once it gets commercialized. So thinking about that from the beginning, that how do you fit yourself into today's or tomorrow's ecosystem, definitely gives a niche within the competition out there for the same kind of product.
So, you know what, I asked for questions and a couple of them came in and you guys are diligently typing answers to them. A lot of the questions were, how do you stay involved if your startup doesn't make it? How do you show your technology without giving away your big idea? And what do you do if the market isn't there yet? Like if you're trying to create something and there isn't yet in the market. So I'm going to throw that out and see if any of those 3 questions inspires one of you to speak. The last thing I want us to do is give us your bit of inspiration. Like what is the most important thing that you want us to know about the future of investment in energy and climate technologies? So it's a blend. It's a blend question again. Who'd like to go first? This is not a shy crowd. So Phoebe.
Okay, I'll go. I'll go. Yeah. So a lot of times, like VCs are investing in companies that are not serving the market that exists yet, right? So we have invested in zero Avia before hydrogen is a thing. So it's so I think if you're thinking about, hey, the market's not there, there are two questions that I would ask you. One is it fundamentally make sense, like the law of physics? Does that make sense for you to go through that? Do you think that there is going to be a market in the future, in the next 3 to 5 years or even longer? And if yes, the second question is, do you have the tenacity of bringing that to fruition? Because when Elon Musk did the Tesla, a lot of people laughed at him, right? So are you able to kind of take the guts and do that and kind of turn through, even though there are a lot of obstacles in the future? So, but I think it's like a really, really exciting time, right? There are a lot of capital around, there are a lot of really inspiring people around. So I think if you are believing in your idea and you check all those two check marks, you should definitely like take the risk and do it. Yeah.
Do we have one more person who wants to answer? And then we're going to start talking about our networking, because this conversation continues in the next room. Who'd like to go?
I'll just quickly try to respond to the question about what if you're in a seemingly competitive space, or you're concerned that your idea might be shared with somebody else. The existence of a little bit of competition is actually probably an advantage. And so don't let that be the deterrent, but you're going to want to understand, who is, participating, who might be potential competition, but who might be a complementary partner one day in the future. I'm struck by how many startups will come in, and when they are asked the question of who is their competition, they say, well, we don't have any. You probably do. It just means you haven't asked enough people who you think my competition might be. So I encourage you to go ahead and stick to it, even if it looks like it might be slightly competitive. I'll just end that with saying that I think a lot of people like me, well, not like me, I'm not going to say that, take that back. I used Netscape years ago, thinking that was going to be the incumbent. And I bet most of the people who are on the screen or listening to us right now never used Netscape, just as an observation. Look it up.
Any other final thoughts? We have a few minutes. We can go a little over. I want to make sure we get the good stuff.
I'd just say on the encouraging side, this is the most exciting time to be part of the energy industry on a global scale in over 100 years. We're in a fundamental point of energy transition that's affecting every aspect of business and culture and society. And man, I can't imagine wanting to work in any other fields, says the energy investor, right? But this is incredible. And I encourage all of you that there's, it's easy to get caught into the minutia. And whenever you're working on hardware or software, my gosh, you're 2 miles deep into any problem solution set. And, make sure that you step back from time to time and you look at the landscape. And because in that forest, there is just some incredible entrepreneurs and incredible innovators that are being drawn into the space. And there's just this incredible buzz of energy around energy. And I'm excited to see what y'all as this next generation are going to come up with, which is way cooler than what any of us came up with before you.
Unless anyone has final thoughts, I kind of like that one. I think that's an important thing. All right, so thank you all so much for joining us. I want to say another shout out to Kristen Whitlinger and Caitlin Haas-Conrad, who have been behind the scenes, as well as Brian Yeske, who's been our media tech for this entire week. Thank you. Thanks also to Sarah Gomash from NREL and the entire team at NREL, Joe Simon and et cetera. There's just so many people that we've worked with on some incredible events this week. We are going to jump over and bring your virtual cocktails with you because we're going to be having a mixer. So we have just put the virtual networking mixer Remo link into the chat, made it super easy for you to just jump right over. And with that, I want to say thank you to these panelists, my friends, for being a part of not only bits and pieces of this week. Some of you stayed on longer than you had to. So I really appreciate all of your efforts. It is a remarkable time to be working in energy, as Josh mentioned, as others have noted. There is significant work to be done, and there is room for everyone. So I just want to say how much I appreciate all of you, the work that you do day in and day out. And I look forward to all of us continuing to move this forward. So with that, we're going to sign off until we get into the next room. I will see you all there. I'm bringing, I think, some champagne, maybe. I'll see you. Thanks.
Thank you, Anna. Thank you all.
Thank you, Anna. Thank you, everybody.
Thank you. See you soon.